जयप्रकाश,
Yes, sir.
ओम सर कहाँ है?
Yes, I am here, sir.
अच्छा हो गए। मुझे इसमें दिखाई नहीं दिया एक्चुअली ना, इसलिए।
Okay.
हाँ, इसीलिए मैंने सोचा कि कहाँ गए।
No problem.
I think Jadoun sir has already connected.
Yes. Are you there, sir?
Yes, sir.
Okay. Welcome, sir. How are you, sir?
Thank you, sir. Thank you. Fine, sir. Fine. What about you?
We are fine. Thank you. So we'll start sharp at 2:30, sir. And
Okay.
Our student volunteer will introduce you, and then you can start, sir. Okay. So
Okay.
we'll wait till 2:30, sir.
Okay.
Okay, sir.
From Department of Electrical Engineering, MNIT Jaipur. Previously, he was faculty in the NIT Delhi and NIT Hamirpur, India. He is a member of IEEE PES Smart Grid Community. His area of interest are economic operation of power system, hydrothermal scheduling, multi-area ED, soft computing techniques, renewable power generation, condition monitoring of electrical apparatus, DGA, health monitoring of power transfer, and AI technique. Without taking much of your time, I would like sir to take session and enlighten us. Dr. Vinay Kumar Jadoun, sir, please.
Thank you so much, sir, for nicely introduction me. So, sir, is there any present now, no, sir?
Yes, your screen is not visible yet, sir. Now, yes, your camera is on.
Not visible? Okay.
So please share your screen.
Yes. Is it visible? Not visible? I am
Yes,
audible, not clear?
Yes, sir, quite clear, sir.
Okay. So should I start, sir?
Yes, sir, please, sir.
So go
Okay.
ahead, sir.
Okay. Good afternoon, everyone. Today my lecture is on smart grid technology. These are my detail. You can note down that my email ID and research interest. So what is exactly smart grid? So generally, smart grid is an electrical grid which includes a variety of operations and energy measures including the smart meters, smart appliances, renewable energy sources, energy efficient resources, and okay. So there are different definitions are available related to the smart grid. That a smart grid is an electrical network that can cost efficient integrate the behavior and actions of all the users connected to it, like generators, consumers, and those that do both in order to ensure the economically efficient, sustainable power system with low losses, high level of quality and security of supply and safety. This is the important measures in related to the smart grid. So generally, smart grid employs the innovative products and services together with intelligence monitoring. How we monitor the system by the effective way, and how we effectively control the system. Okay, then better communications and self-hearing technology in order to number one that better facilitate the connections and operation of generators of all sizes and technology. How we facilitate the connection, there should be a proper connections smartly, how we connect it. Okay, the network system is proper, so that this technology. Second one, allow consumer to play a part in optimizing the operation of the systems. So nowadays system is more complex, so there are many techniques are available where we can optimize. Okay, how to optimize the cost, optimize the system, better demand response. Okay, these are the many technologies are available, so we can work out. There are many research are going on in the smart grid related to the how we properly integrate the electrical vehicle, how we properly maintain the demand side management, energy meter applications, and many more. Okay, so these are then provide consumers with greater information and options for how they use their supply. Like for demand side management, we are having a we can manage the peak side demand. So how we shift the peak side load to the non-peak hour. So there are many policies are available where we can that inform the or that encourage the consumer, then they can shift their demand from the peak side to the non-peak side also. So it may be these terms are available in demand side management problem. And significantly reduce the environmental impact of the whole electricity supply systems, how to minimize the emissions which is generated from the coal plant or some others. So it is better to maximum utilize the non that the renewable sources which are having a zero emissions. So then maintain or even improve the existing high levels of system reliability, quality, and security of the supply, and maintain and improve the existing services efficiently. So these are all some points which are related with the smart grid. Next, we discuss about the smart grid technologies. So generally, smart grid technologies are defined as the self-sustained systems that can find solutions to problems quickly in an available system that reduces the workforce and target sustainable, reliable, safe, and quality electricity to all the consumer. Okay, so generally for this technologies, it may be involved as how we integrated the electric vehicle to the in the grid. Okay, that may be the most popular problem nowadays. Then demand side management, obviously I told you, and how we are having some market constraints like bidding, pricing mechanism. So bid based we can optimize the problem. We can that target is to maximize the total profit. Okay, so some are having different objectives. So these are all related with the smart grid technologies where we are quickly find the solutions with an efficient way, and it may be ensure that the system supply should be reliable, safe, and the quality should be proper. So in this respect, already different technologies applications can be seen from the perspective of researchers and investors. So even though these technological application study constitute an initial steps for the structure of the smart grid, so they have not been fully completed in many countries. So associations of initial study for the next step in smart grid application will provide an economic benefit for the authorities in the long term and will have established and to be compatible with every applications, so that all smart grid applications can be coordinated under the control of the same authority. So this is the general diagram for smart grid framework. You can see here, this is the generating stations, transmission system, distribution subsystems, and this is the consumer. This is the, in this particularly, we have a two-way communication link here. So in this particular generating stations or generations, they are two-way communication amongst this between the power markets and this regional system operator. Okay, and there may be a control centers. Okay, these all are having a two-way communications with this generation side. Then second one is the substation automation system. It has a two-way communication with the control center. Communication between it can be happened amongst between this control center and the substation automation systems. Then these control centers having a two-way communications with the generations, power markets, seasonal system operators, and the distribution control centers. Then we have a distribution automation system. Okay, so there will be, this one is a two-way communications. You can see here, this is the consumer side where we have a energy service provider. Okay, this is the DR automation systems, unit utility, AMI, automatic metering, advanced metering infrastructure. Okay, so these all are interconnected. So nowadays, in the smart grid frameworks, all are having a two-way communications. So now just we can look at the problem statements. This problem is done by my research scholar. So I just present you this. So in this problem statement, deterministic multi-objective optimization problem is proposed for this optimal scheduling of microgrid by considering a mix of multiple dispatchable and non-dispatchable like renewables distributed energy resources, which can exploit the maximum benefit of such resource over different scenarios. Second, the impact of to grid and grid to vehicle with the load variance of the main grid has been considered and investigated for the microgrid systems. Dynamic pricing environment have also been considered to facilitate this fair competitions for all the microgrid stakeholders over multiple scenarios and different benchmark systems. And here an improved variant of elephant optimization is proposed to overcome some of the limitations. So generally in this problem, we are trying to emphasize that there may be some DG, distributed generator systems are there. So how it affect the cost and emissions when we incorporate the renewable sources in the systems, how it affect the cost. And other thing is that we are incorporating the electric vehicle in with the grid. So this is the type of problem where there may be a islandic operations and the grid connected operational sources, and we connect the electric vehicle and we are having a dynamic pricing with a flat pricing. So how it affect the cost of operation? This is the main objective of this particular work. Okay, and here we are implementing PSO, EHO, or improved EHO optimization techniques, and we check the performance, how these optimization techniques affect the cost or affect the performance or affect the solution quality. Yeah. So in this, this is the modeling of different distributed generation. So in this particular part, we are having a deterministic modeling of different dispatchable and non-dispatchable distributed generators, considering for microgrid systems are presented such as DE and fuel cells and MT, microturbine, PV, WT, and EV, wind and electric vehicles. These are all interconnected, and we discuss the modeling of these. So in this, EV charging and discharging models are considered for vehicle to grid and grid to vehicle applications in this proposed model. So first one, discuss about the generation characteristics of DG. So this diesel engine model, here this is the equation for diesel general motor. Here CDE is the fuel cost of this diesel engine. Okay, alpha, beta, gamma are the coefficient of the diesel engine. Okay, PDE is the output power of the diesel engine, and this del T is the length of period, is a dynamic type of programming where time constants is there. Okay. Other one is the fuel cell model. In this particular model, this is the equations where CFC is the gas consumption cost of fuel cell, CNL is the price of the gas, I think this is PFC, sorry, is the output power of the fuel cell during the time del T, NJ is the efficiency of the fuel cell, L is the net thermal value of the gas. This is the micro turbine model. This is the equation for MT model. Here CMT, okay, represent the cost of MT. Okay, so here efficiency, this MT is equal to X P MT by PR Q plus this one. So CMT is the fuel cost of micro turbine, and this one PR is the rated output power of the micro turbine. PMT is the actual power output of the micro turbine. CGAS gas is the cost of natural gas. LHP, which is represented here, is the low calorific value of the fuel. Okay, this one MT is the efficiency of micro turbine in the period T, and X, Y, Z, C are the coefficient for this equations. This is the solar PV model. The equation for solar PV model. Here you can see that PPV is the actual output power of the solar PV. PSTC is the maximum power output from solar PV at standard test conditions, and this one GING is the intensity of light which is falling on the solar PV. GSTC is the intensity of light falling on the solar PV under standard test conditions. K is the power generation temperature of the PV. TC is the temperature of the PV cell, and TSTC is the temperature of the PV cell under standard test conditions. The wind turbine model. Okay, this is the equation for wind turbine model. PWT is the actual output power of the wind turbine. Okay, V is the velocity of the wind flowing, and PR is the rated power of the wind turbine. Okay, where this A and B we can calculate it with the help of this formula, that A is equal to PR upon VR cube minus VCI cube, and B is equal to VCI cube upon VR cube minus VCI. Here VR, VC0 and VCI are the rated wind speed. This one is the cutoff wind speed, and this one is the cutting wind speed. Okay, so this all are the generator characteristics model. Next is the charging and discharging model of electric vehicle for grid to vehicle and vehicle to grid applications. So first one is the daily driving distance of EV and SOC of the battery. So the probability density function for the given distributions can be expressed as follow. This is the formula. Okay, we can check, we can calculate the probability density function. Here, this is the formula FSC equal to 1 upon root 2 pi expression of this one. The SOC is the state of charge of electrical vehicle, which can be expressed as 1 R, where D is the daily driving distance, R is the maximum driving distance of the EV when its battery is fully charged. Okay, then state of discharging, this one, so it may be SOCM minus SOC EV minus min. Okay, and this one is the for charging, so you can calculate it. And the charging and discharging power of EV. So here this is the table where we can get the charging discharging of EV, which can be divided into 3 different modes. Number 1, we are having a slow mode, conventional mode, and fast mode. In the slow mode, the rated voltage is 220 volt AC. Rated current is 16 ampere. For this conventional, it may be same 220, and rated current is 32 ampere. And for fast, 400 volt by 750 volt, and rated current is 125, 250 ampere, and 400. Then starting charging and discharging time of EV. So this is the expression for probability density function of the starting charging time of the EV, which is F fast with respect to time equal to, this is the expression. Here we can calculate this value mu as this one by using some simulations, and we can get the exact value, or we can find a probability density function based on the graph available and data available differences. Then the calculation of charge and calculate the total time required to charge the EV. So time of EV is equal to SOC charge into S into 60 upon T charge. Here this T charge dot M is the time required for charging the battery. S is the capacity of the battery, and T charge is the power required to charge the EV depending on the charging mode. And this we calculate with the help of the previously formula, this one. Here we can already calculate this one. Here, from here we can calculate this SOC. And the total time for which EV will be discharged as, so this is the time which can calculate when the this EV will be discharged with the help of this formula. Minimum of SOC discharge multiplied with S means is the capacity of the battery, okay, multiplied with 60 divided by P discharge, the power required to discharge EV, and comma 1440 minus T star. Okay. Then calculation of EV charging and discharging loads in the microgrid. So here with the help of this Li equal to summation of M equal to 1 to M P charge M comma I minus P discharge. So where Li is the total charging ith minute, and is the range. It may be from that, maybe we can calculate 1440 or depend upon your simulation study. V charge and discharge is the charging power demand and discharging power of M EV during the ith minutes. Okay, so this minute depend upon your calculations. We can take it as, we can assume it is 1440. So with the help of this, we can calculate the EV charging and discharging loads in the microgrid. Now the objective functions. So the aim of this particular research is to achieve the optimized model with minimum environmental impact and lowest cost of operation, while ensuring is stability and safety operations. So here the operating cost of microgrid, here it can be calculated. C1 is the operating cost of microgrid. This one Fi is the fuel cost coefficient for ITG. Okay, PIT is the output power of the ith generator at the T tower, and OM is the operating and operation and maintenance cost coefficient for IDG. Okay, and C grid is the cost of trading the power between grid and the microgrid. So this objective consists of the operating cost, operation cost, and the maintenance cost. So here we can calculate the C grid. Okay, is equal to this one PIT minus this form. Okay, and second one is the pollutant treatment cost. Here this it can be considered as C2. Okay, and it may be calculated with the help of this formula. So C2 is the pollutant treatment cost of microgrid. CJ is the fuel cost coefficient for the ith generator. Yij and this Y grid J is the output power of ith generator at T tower. Pi is the output power of the ith GG, and P grid is the power trading between the grid and micro. So in this particular case study, we are considered the COX emission, SOX emission, or NOx emission. Three types of emission we have considered. Okay. Now the next we are considering the load variance of the grid. Generally, load variance is why we are incorporating is because for stability of power system and to promote the economic operation of the power grid, it is equally important to minimize the peak valley gap in the load. So this will ensure the safe and reliable operation of the power systems. So the load variance can be described as the difference between peak and the valley load. So the expression is given by this one, F equal to 1 upon T, T load T plus P EV minus this one. And P average, we can calculate it with the help of this formula. Okay. So here, this is the power, this is the load with respect to time. This is the power from this EV with respect to time. This is the actual power and the average power. And average power is the 1 upon T. T is equal to 1 to T. Capital T is the time. So for a day, we can take as 24, 24. And P load plus PV minus summation of this one. With the help of this, we can calculate this load variance of the grid. Then is the multi-objective optimization. So there are many ways we can solve this multi-objective optimization. Either we can use the we can solve this with the help of fuzzy membership function, or we can solve it by the goal-oriented programming, and we can solve it by using the weighting factor method. So general application is the weighting factor method, where lambda is the weighting factor. It may be considered as 0 to 1. Okay, is any value. Suppose we are considering lambda equal to 0. Lambda equal to 0 means this term may be 0, so you can only calculate the variance. Okay. Suppose lambda equal to 1. So lambda equal to 1 means we can already calculate the cost. C1 and C2 means pollution and the total cost, operation and maintenance cost. So in this particular study, when we are going through the many simulation result, it may be better to give the equal weightage to both the objectives. So we are considering lambda equal to 0.5 for this particular study and giving the equal weightage to both the objectives. Now the constraints which are considered for this case study, like number one is the power balance of the microgrid system. It may consist of total power generated from all the DGs, including these renewable sources also, if we are considering. It should be summation of P grid, whatever the power considered from the P grid should be equal to P load plus PEB. So P grid it may be a negative or positive, depend upon the, either we can take a power from the grid or we are giving the power to the grid. Okay, so accordingly it may be changed. So in the output power limit of the DGs, so all the DGs should be within the limit P min and P max. The ramp rate limit which I consider here is the total power at the current time, what is the power output, and the previous time what is the power. It's the summation, the mode summation should be equal to Ri, the ramp rate limit which is given. Charging and discharging of EV, so all the power from the EV, it should be within the limits P min and P max. The capacity constraints of EV battery, so here we are having the SOC, right? And there should be a minimum charging and a maximum charging time, so it should satisfy this constraints. So these are the constraints. Other one is the power, transmission of power constraints. So okay, so power should be within the limits minus max to plus max. I think it is visible. Okay. So here it should be maximum power negative to 0. So this is the transmission power constraint limit. So these are the constraints which are considered for solving this problem. So for solving this problem, we are considering here PSO, IHO, and HO. So first we discussed about the PSO. Generally, PSO is the particle swarm optimizations algorithm which is inspired by the behavior of social beings. The agent referred as the particles are influenced by the best position, and the optimal solution is achieved by adjusting themselves according to the best positions. So these are the this is the flow chart, and this is the equations where we can solve this, implement this PSO problem. So in this particular PSO, this is the velocity equation, or this is the position equations. So velocity, it may consist of W is the inertia rate, V is the Vk is the old velocity, C1, C2 is the coefficient, and R1, R2 is the random value which are varied between 0 to 1. This is the best value. This is the current positions. So, and this one is the G best value. This one is the current position. So accordingly, it can vary. So generally in PSO, there are 3 components are involved. This one is called the initial component. This one is called this. Just a minute. So this one is called the initial component. This one is called the cognitive component. This one is called the social components. Okay. So here we are having, suppose 10 particles. So among 10 particles, every particle has a fitness value. Okay. So we are having a 10 fitness value. So initially for this every particle, this 10 fitness value is called the best fitness for a particular particle. So we are having a 10 fitness, means 10 best positions of the 10 particles. Okay, so accordingly we can check the best. So every particle, after getting the value of P best and G best, so every particle check their P best value and the global best value. Accordingly change the position by using this equations. New position is old one plus the velocity. The main objective of this PSO that every particle achieve the best value or it just reaches to the global best value. Ideally, okay, but practically they all are nearby to the optimal value actually. Clear? So this is the terminology of the PSO. The PSO is worked accordingly. So this is the flow chart. You can start. Okay, initialize the parameters of PSO. Initialize the parameter of PSO means we have to choose the initial value of W. W may be vary between maximum minimum minute. Some of the authors they are considering the W max equal to 0.9 and W may equal to 0.4. Some of the authors they are considering W min equal to 0.1. Okay, and initially velocity you can consider as 0. You can take a random value. C1, C2, it may be considered as 2 generally for classical PSO, but author has changed most of the authors, they have changed the value, varied this value because these are the simple value which can play an important role for handling this PSO because PSO having a problem that it can stuck in the local optima. So, okay, so how, because exploration is better, but exploitation is not better in the PSO method. So it is better that how we can escape from the local optima. So they can vary the C1, C2 value, they can split the value. There are many researches going on. You can go through the paper. So in the classical PSO, C1 and C2 may be considered as 2. Means for suppose we are having a first iteration, after getting the new horizon value, we have to satisfy all the constant value, and accordingly this P best may be changed. If current P best is better than this, otherwise you can just keep the best value. So in this particular input parameter of PSO and initialization position velocity of the particle, we can put here. Then calculate the fitness value of each particle and determine the individual optimal value group. Means after calculating the fitness value, every particle has has their own P best value, so it can be calculated with the help of this fitness, and the best value then update individual optimal value and the global value like P best and G best you can update. Now you can, this is the termination criteria where if you can have these the maximum iterations. If no, so it can update the weight and the learning factors, and accordingly you can change the positions, okay, and velocity, and change the P best and G best accordingly. After getting this, you are reached the maximum iterations, so you then display the result. So this condition may be changed, depend upon you. Okay, either you can put a condition like if all the particles having the same fitness value, there is no chance of any modification terminated. It can save the time of this. Suppose you are having a 1000 iteration and all the particles are converged in within a 200 iterations, so other 800 iteration is the best. Okay, it may already increase the time of computation, so it's better you can preserve the best value, and if all values are common or same, there is no chances of any changes, so okay, you can terminate the program. So this may be the condition you can apply here also. So this is all about this particles optimization. Accordingly we can apply here. Other one is the EHO. This is the flowchart of EHO. So generally EHO is the swarm based bias part search method for solving the optimization problem. Okay, which aim to solve the optimization problem. Like there are different types of problems, it can be easily solved. So in this particular optimization techniques, it is inspired by the elephant searching for foods. Okay. So here the elephants are divided themselves in two groups, which represent two methods of finding the best solutions. Like the male elephant search for the food in the different dimensions of this that search space, and whereas the female elephants localize search in the region of close proximity. So generally, in this every obtained technique, the exploration and exploitations are the two important components, the two important concepts which can be balanced. If these both are balanced accordingly, you can control the technique. Otherwise, if it's not balanced, if you are not properly searching the area, you are not properly explore, so obviously you cannot get the best solution. There may be chances. Okay, and exploitation is also important. Okay, so both balance should be proper. So in this particular EHO technique, the male elephants it can perform the exploration operation, and the female elephant it may be perform the localize or exploitation. So generally, the two factors solution is depends are the clean updating operators. This factor is responsible for updating the current position of the elephant with respect to the this matriarch. Okay, this is calculated with the help of this formula plus alpha, this best value and the current value. Okay, the position of the fittest elephant in the clan is updated like this one. Operator in this factor is used to implement the situations where the male will leave the clan to search alone, and the elephants with the worst fitness is given as this one. Means every time, if suppose some elephants having the or some particle having the worst fitness, it can be replaced by the best one. So male elephant is replaced by the other better male elephant in the clan. So this is called the separation operations. So accordingly, with the help of these two factors, we can control this EHO. So you can display the result. This is the discussion about the EHO. Okay, this is the newly developed technique. Okay, it's performed better because it having less number of control operators as compared to the PSO or other techniques. Okay, with the help of these two factors, we can control these techniques. Okay. So in this experimental setup, we have tested these techniques on two test systems, 4DG and 6DG systems. Okay, so each test system subject to three different scenarios. So in this scenario one is the optimal scheduling of microgrid considering only cost minimization. We are having only C1 and C2 cost minimization functions which are considered in this particular scenario. Second is the optimal scheduling of microgrid considering the cost as well as load variance. So here we are incorporating the load variance with the cost, and we can check the performance if they actually include the load variance, how this system or how this problem it can be treated. Second one, suppose after it can be visualized that in this simulation result that by incorporating the load variance, the cost total is increased. Okay, obviously it may be increased. So how we can manage, how we can reduce? So we are integrating the charging and discharging current, charging and discharging of the electrical vehicle with connected to the grid. Okay, with this particular problem, like optimal scheduling of microgrid considering the cost and variance minimizations when EVs are connected to the grid. These are the three different scenarios we are considering for. And these three different scenarios are applied on these two test systems. Okay, so we are also considering some cases here. So each scenario has 6 different cases. So 6 different cases means case 1, the microgrid is on islanding mode and it will not deliver power to the grid. Okay, case number 2, this same thing is there, microgrid is on islanding mode, but here renewables energy sources are considered and it will not deliver. The case is similar, but here renewables are not considered, here renewables energy sources are considered. We can check the performance, which if we include the renewable energy sources, so how cost is reduced, how it may affect. Okay, So that's why we are considering renewable here. Third case is, this case consider that the power will be transmitted from main grid to microgrid only when it is economically cheaper for the microgrid to purchase power from the than to generate power, but the microgrid will not deliver power to the grid. In this particular case, okay, you are taking the power from the grid, but depend upon the situation. So same thing here. In this, renewable sources are not considered. In the case number 4, renewable energy sources are considered here. So we can check the performance. The case number 5, all DGs, means all DGs and renewable sources as well as grid will participate in the optimal scheduling. Means like this is the grid connected problem with the consideration of renewables and all the other DGs. And microgrid will deliver power to the grid if it is economical. So this is the case when we are having a fixed pricing concept. We are having a fixed pricing, so we can check the performance. And this is the case number 6, where we are having this free trading of power between this microgrid and main grid. Means we are having a dynamic pricing concept apply here. Power exchange between the two, considering the dynamic pricing concept, and thus giving the maximum benefit to the both the system and the consumer. Clear? So this 6 case, we are applying these techniques to solve the problem with respect to 6 case in each scenario and for the both test systems. So this is all about the experimental setups. Now we discuss about the result. So first we discuss about the DG parameter for this test system. So test system 1 has 4 DGs. DG1 is the diesel engine, DG2 is the micro turbine, DG3 is the solar PV, DG4 is the wind turbine. Test system 2 has 6 DG consisting of DG1, 2, 3 are the diesel generators, DG4 is the fuel cell, DG5 is the solar PV, 6 is the wind turbine. This is the DG parameters for this test systems. Now scenario number 1, okay, optimal scheduling of microgrid by considering the operating cost minimization only. So this is the result obtained by the PSO, EHO and improved EHO. This is the cost, and this is the cases. Case number 1, 2, 3, 4, 5, 6. We are having a 6 cases. So scenario 1, in the test system 1 we are applying here. We can check here that all these costs are approximately similar, but if we check this here, so this is actually small system, so the changes in cost is very negligible or very minimum. You can check here in case number 1, the cost obtained by the improved EHO is better than this PSO and EHO. Here you can see that after applying the renewable sources, this is the case where renewable sources are not applied. This is the case where renewable sources are applied. You can check the cost is reduced. Obviously, whenever we apply the renewable sources, cost is reduced. Same thing happened in case number 4 also. Okay. So in this both the cases, renewables are not considered. In this cases, renewables are considered. You can check by incorporating the renewables, obviously cost is reduced. And after that, when we are having a fixed pricing concept or we are having a grid connected operation, you can check this cost is again reduced. Here renewables are also included. We are having a fixed pricing concept and a grid connected operation. But when we incorporated dynamic pricing concept, okay, so you can see that obviously cost is reduced. In all the cases, you can check when we apply the renewable sources, obviously cost is reduced, or when we apply the dynamic pricing concept, cost is reduced as compared to the other cases. And you can check this amongst this PSO, EHO, and improved EHO. Improved EHO getting the lower cost or minimum cost as compared to the PSO and EHO. Okay, so this is the cost comparison for different cases and optimization metrics for the test system 1 in scenario 1. Same thing happened when we are having a test system 2 in scenario 1. Again see that by incorporating the renewables, obviously cost is reduced as compared to C1 and C3. And you can check when we applied grid connected operation and fixed pricing concept, so cost is again reduced. And we applied the dynamic concept, so obviously cost is reduced. Okay. So case number 6 having a less number of is the minimum cost as compared to the other case. And obviously you can check here that cost obtained by this EHO is better than the other PSO and the EHO. Clear? Now Second, scenario number 2, which are having the optimal scheduling of microgrid by considering the operating cost and load variance. By incorporating the load variance with the operating cost, how this system perform. So you can see here, same that case number 1, 2, 3, 4, 5, 6. Okay. So here you can see, if you can check that cost is suppose in this particular is 3982.923. Here you can check it may be slightly increased. So by incorporating the load variance, you can check that cost is increased in this case as compared to the scenario 1. Okay, but concept is similar when we incorporating the renewable sources. Okay, so obviously cost is reduced when we incorporating the fixed pricing concept and grid connected operation. Cost is again reduced, and when we apply the dynamic pricing concept, the cost is changed. Okay, but as compared to scenario 1, scenario 2 having the slightly greater. Okay. Same thing, this is a cost comparison of different cases, allocation method for test system 2. Here also same thing happen in all the scenario or all the cases. You can see that after applying the renewable, obviously cost is reduced, but when we apply this dynamic pricing concept in the grid connected operation, when renewables are also incorporated, cost is changed with respect to case number 1 to case number 5. Again, you can see that cost obtained by this improved EHO is better than the other one, PSO and EHO. This is a small test system, so obviously there is no drastic changes of the curve, but when we compare this cost in terms of percentage or overall year, so there will be difference. Okay, so that's why there is slightly change in the cost. You can see here 1626.947 obtained by PSO in this case, 1610.637. This is a change, 26 to this one, 16 difference. Okay, obtained by EHO here 1603.4. So there may be a changes in cost here. You can check it. So that's why improved EHO performed better than the other one. Then scenario number 3, optimal scheduling of microgrid by considering the operating cost and variance minimizations in the presence of EV. So you can check here that by incorporating this EV, obviously cost is reduced, because here when we apply or integrate the EV, we can check that V2G, that vehicle to grid operation perform when there may be a peak time, and grid to vehicle may be a non-peak time. Okay, so accordingly we can check, and we are having a different different EVs. So which EVs are performed, accordingly it may change depend upon the load profile. So when we incorporated this EV in the grid, so obviously it may the cost is reduced, and the effect of load variance we are already incorporated. So it can also be minimized the cost here. You can see that in this particular case number 1, case number 2, 3, 4, 5, 6, again renewables are incorporated, cost is reduced when we are having a fixed pricing mechanism with a grid connected operation. So cost is again reduced, and we applied dynamic pricing concept. Okay, cost is reduced as compared to the other cases. You can also see here that here 2890 is the cost obtained by PSO, 2855 cost obtained by the EHO, and 2853 is the cost obtained by the improved EHO. So obviously improved EHO performed better than the other two techniques here. Same concept applicable in case of test system 2. You can also see here that cost is reduced is the 6 test system. Obviously here also 997, 947 and 944. Okay, you can see that case number 6, when we apply dynamic concept, grid connected operation, renewables, all are here. So obviously cost is reduced as compared to the among other cases. Okay. Next one is the comparison of the scenario. Now after incorporating this, suppose scenario 1 having only cost minimization, scenario 2 having load variance, scenario 3 are load variance cost with respect to the interconnection of EV. So how we can change, or how the cost is changed according to this scenario. So in this particular, you can check, this is the cost in different scenario obtained by the proposed EHO or IEHO with respect to each case. Here we are having 1, 2, 3, 4, 5, 6 case. This is scenario 1, this is scenario 2, this is scenario 3. Scenario 1 having only optimal cost of operation. Here cost plus load variance, in this cost plus load variance plus EV. So you can see here that the cost here is in this particular case number 1, scenario 1 is 3982.916. Here this is 0.917, slightly increased, but when we are having electric vehicle, so it is 3896.027. You can see by incorporating the electric vehicles, obviously cost is reduced. Okay, same thing in case number 2, you can see that 3649, here 3649.986.34 is slightly increased in scenario number 2, but the cost in scenario number 3 is 3544.86. You can see the difference. Okay, now in this particular case number 3, 3990.278, whereas 3990.296, slightly difference in cost, but this is because of load variance. But then in scenario 3, you can check 3909.1. You can see the cost is changed. Same thing in 4, 5, you can see check this one, 6, 3381.09, 3387. You can see here cost is increased in the scenario number 2 by, but here 2853.131. See the difference. Okay, so this is the important concept when we incorporating the electric vehicles, and how effectively we can charge the vehicle and we can discharge the vehicle. So accordingly, we can minimize this operations, or obviously we will get the best cost or the minimum cost of operations. Same thing happened in case of test system 2. Test system 2 obtained by proposed EHO, and different scenario you can see here. Here also 2213.27, 2213.27 approximately similar, but here when we incorporating this, it is 2101. Here also 1891.187, approximately similar, but here 1787. Okay, you can see here 2213, 2227, so it may increase, but here 2097. Same thing 1869, 1905, it is increase here, but here 1813. Case number 5, 1544, 1731. Here 1437. This is in the last case 1426, 1603. It is increased. You can see this case. Okay, it is increased. This time too, but here 944.253. Okay. So this is the effect that we want to see, that by incorporating the load variance, how the cost is changed, and by incorporating this effective charging and discharging of electric vehicles which are connected or interconnected with the grid, how it affects the cost of it. So obviously you can see in all the cases, in all the scenario, okay, when we incorporated the renewable sources, so obviously cost is reduced. When we incorporate the fixed flat price concept in the grid connected operation, cost is again reduced. And when we apply the dynamic pricing concept, okay, interconnected grid and renewable sources are there. So obviously in case number 6, cost is reduced in all the cases, in all test systems, in all scenario. And also you can see that the comparison of the scenario, that in a scenario 3 generate lower cost as compared to the other scenario, because of the properly interconnection of electrical vehicle. So that is the main thing of this particular study, that both the conventional and renewable DGs are considered for optimal load dispatch of microgrid in domestic environment. Due to the low cost of production, zero emission renewable sources like PV and WT always generate power at full capacity. Among other conventional DGs, FC are cheapest, as it can be verified from the result. The objective is to generally achieve the lowest cost of generations after fulfillment all the constraints. And the result obtained from this simulation verify that if free trade of power is allowed between the microgrid and the main grid, the process of power generations can be more economical, and further introduction of dynamic pricing into the scenario proves the even cheaper cost. The impact of EV in the scenario is very significant, as G2V operation during the off-peak hours and V2G operation during the peak hours support microgrid to operate in its more. Also, the power production cost of the microgrid is cheapest for all the cases in this scenario. Scenario number 3. The implementation of this EV operations in this scenario not only help in cost management but also help in stabilizing the grid. So, sorry. So again, the last one is the use of SOM-based operating techniques such as PSO, EHO, or improved EHO has given very convenience output, and among these 3, improved EHO outperforms for providing the best result with the minimized cost of optimal scheduling because of its extensive and improved express. So depend upon you that you can either modify. There are many techniques available in the area, and you can see in the literature there are many new techniques are available. Every techniques have their individual quality. Okay, some techniques having a better exploration, some technique having a better exploitations. Okay, so their research are going on. Either they can apply normal. You can see PSO. There are many research going on, or already it can be done. Okay, they can modify ESO by different meaning. Same thing happened here the newly technique, so it are also having some problem. So we can sort out this problem by in the improved version or check the performance. This is the small test system, so obviously it's not actually drastic changes, but there may be a change. We can check the all. We can calculate all the result with after 100 try and check the all the STDs and worst cost and the minimum and the mean cost and average. And it's average cost is better. Average in STD is better after getting the 100 try result among the all the cases. So I improve EHO getting the better result. So that's actually from my end. So this is my Google Scholar profile, Scholar ID. You can get my paper. It's available online. So thank you so much from my end.
Okay. Thank you so much, sir. Thank you so much, sir, for your nice presentation. Actually, it was really nice to have you, sir. Now, the session is open for questions. As I can see, there are 2 questions in the chat box, sir. If you could see them there. One of the participants has asked the same.
Okay, so sweet. I'll check. What does the particle represent in this problem? Okay, so generally particles may be it may be the random generations like suppose every DG have a power output minimum suppose DG have 1 DG having a power minimum power is 50 and maximum is 100 for example. So the limit is 50 and 100. So randomly you can calculate the value. Okay, like suppose after having a random value, particle value is 75. So it may be termed as particle. Okay, and particle also consider suppose we are having a 4 DG connected. So 4 DG means 4 different strings are there. DG number 1 having a different value, randomly calculated. DG number 2 having a different value. DG 3, DG 4. Okay, combinedly they can calculate the fitness value. So these 4 DG represent 1 particle. And after getting the fitness value, they are having a single fitness value. So 1 particle having the 1 fitness value. Clear? And second one is the elephants or particle represent the same set of parameter in all the scenarios. Please explain what does the particles or elephant represent physically. Physically means I'm not getting actually. Here elephant and particles both are equal. Elephant means which are heavy elephant and this a female elephant. So the process is we are calculating at a time 2 process. One process means elephant, male elephant calculate the 1 fitness, female elephant calculate the other fitness. Both are compared and accordingly it can be mixed and we can check this which one is better. Because in the second separation operation we have to calculate the worst fitness of the particle. Suppose the elephant which are having the worst fitness by the new one. So male elephant replaced by the male elephant but a better value. This means the leader is the that female elephant. So we are having a different clay. Suppose in this particular problem we are having 10 clay and we are having a 5 or 6 elephants. So 10 clay means these elephants play an important role for this particular. Okay, so the process is slightly different as compared to PSO.
Okay. Yes. Any more questions from the participants?
Yes.
Any other question? And we will also share the contact details of Dr. Jadoun sir, so that you can directly ask him. Okay.
It is also available in my
So
slide.
I would now request Jayaprakash. Sir, if possible, please do share your slides. Actually, participants asked after the session.
Okay,
So
okay, no problem.
we can provide them the PPT.
Okay, no
The
problem.
PDF form. Yes. Yes, please, sir. So now I would request Jayaprakash. Are
Yes,
you
sir.
here?
Yes, sir.
Okay. Carry on.
Thank you, Vinay Kumar Jadoun, sir, for enriching us with your.
One second. Let me now introduce our head of the department. He is there with us in the meeting. Sir, head sir, Dr. A.T. Akela, sir. He is there. You are able to see them. Yes, sir.
Good evening, sir.
Good evening, sir. Good evening.
Yes,
Yes, sir. Sir, he is Dr. Vijay Kumar Jadoun from Manipal University.
Yes.
And he
Late, sir. After 3:30, I am coming generally. So sorry, sir.
Yes.
Okay, no problem, sir. Okay, sir.
Okay. Okay. Jayaprakash, please.
Thank you, Vinay Kumar Jadoun, sir, for enriching us with your valuable words and esteemed presence. Also, I'd like to thank all the participants. Now, with this session is over. After a short break, Expert Talk 7 will start at sharp 3:45 p.m. IST. Thank you.
Okay, thank you so much, sir. Thank you so much.
Okay. Thank you, sir. Thank you for your nice interaction, and it was really fruitful. Thank you so much, sir.
Thank you, sir. Sir, I will share my PPT.
Thank you, head sir.
Thank you, head sir.
Sir, please. Thank you, sir. Thank you so much.
I am here also, Omari. I will join after 5 minutes.
Yes, sir.
Okay.
Okay, sir. Okay, sir. Thank you. And I will also share the feedback form just now. Please wait.
तो लाइव कर लो उसको।
को 2 साल की सेवा देगी। इसमें केवल मेडिकल काम पर ही
सर नमस्कार सर, नवनीत सर.
Good afternoon, sir. How are you, sir?
सर अनम्यूट है. सॉरी म्यूट है.
Sorry, sir. Actually, I forgot to unmute myself. So I think everything is fine, and I'm not much late.
Everything is fine, sir.
I had to change my location. Actually, one another meeting was there at the location from where I have shifted. So,
नमस्कार सर.
it's all right. You are getting my voice and video both.
Sir, your video is clear, your voice is clear.
Thank you, sir. So, can we start, sir?
Sir,
I
please
can
wait.
see on
Our
the screen. I
volunteer-
can see head of the department. Namaskar, sir. Sir, how are you, sir?
Yes, sir. Sir, pranam.
Yes, sir.
Again. Good evening. Okay.
So we shall discuss, sir. I think this is the time for lecture. We shall we first complete this.
Yes, sir. Yes, sir. I'll start.
I will request Munna, are you there?
Yes, sir.
Okay, please introduce the speaker first.
Good afternoon, all. Welcome to the online short-term course on recent trends in microgrid RTM 2020. We now have Expert Talk 7 to be delivered by Dr. Navneet Kumar Singh, sir. He is Assistant Professor in the Department of Electrical Engineering, Motilal Nehru National Institute of Technology, MNNIT, Allahabad, Uttar Pradesh. Dr. Navneet Kumar Singh, sir, has obtained his BSc Engineering degree in 2004 and MTech degree in 2006 from Allahabad Educational Institute, Agra, Uttar Pradesh. Sir has received his PhD degree from MNNIT Allahabad in 2016. He has supervised 17 MTech and 4 PhD scholars. His research interest includes power system elements, analysis, operation, control and planning, artificial intelligence, artificial neural network, and fuzzy logic in power system, and image processing. Now, I would like to, sir, to take session and enlighten us. Dr. Navneet Kumar Singh, sir, please.
Thank you, student. Actually, I don't know your name, so thank you.
He is Munna Kumar, sir.
Thank you, Munna. Thank you. Okay, so I'm sharing this. I think now my screen is shared. I think my slides are visible now.
Yes, sir.
Okay.
It's shared, but we are unable to see the PPTs. Yes, now we are now. Thank you.
Okay, there may be a little delay in the broadcasting. So
Yes.
I'm starting from the topic I have selected as load forecasting, the tool for power system planning. So I will discuss about this. So first of all, I'm starting from power system planning. Thing is that what is power system planning? So it is to determine a minimum cost strategy. Whenever we plan anything, we go for the, number one, the things must be in the right direction, and number two, that is also very important, is the cost, minimum cost. That is important. So it is to determine a minimum cost strategy for long-range expansion of generation, transmission, and distribution system, adequate enough to supply the load forecast within a set of technical, economical, and political constraints. See these things: technical, economical, and political constraints. And this definition is given by Nadijeka Gurina Borjimurak. So we see these 3 points. These are very important. Any planning, all the kind of planning, whether someone is going to some marriage event or some sports events, any kind of it. 3 things, these are important. Number one, technical. Things must be technically feasible. there must not be any technical lack. And second one is economic. We cannot spend beyond the limit. And as much economics allow, we should follow those things so that the things can be economic, cheaper, and we should invest least. And at the last thing, political, that is very much involved in especially in the countries where we see democracy is there, some government is there, government rules, and they create the rules and regulation, and we need to work within those conditions. And as per in general, we can see or say that planning is a systematic strategy involving engineering and scientific aspects to make a future system capable so as to fulfill the future requirements expected from the system. Now, expected का क्या मतलब है? Expected means we plan. Suppose we are thinking that some marriage is going to plan. Some marriage is there at someone's family, and we need to plan that. So we have to first think that what will be the venue, how much is our budget, how many guests will be there, what will be the food arrangement, any other special arrangements like some cultural event or any other thing we need to organize or not. So all those things need to be taken care of. So we should think in that direction. Means first we need to forecast. We need to foresee the things which are going to happen but not yet happened. We need to take the idea, and this idea we cannot do it direct. We cannot take directly. Like we have. Read some mantra, and by that mantra we got something. There are certain parameters over which we estimate these things. Like, say someone's status, say someone is one administrative officer, some government administrative officer. So we know that particular fellow has a good will get a good gathering, and that gathering may get up to 2,000 or 5,000 or so. But if someone is for a poor person, or maybe a low economic person, we can say that gathering will be 100 to 500. Some village marriage, it will be around 500 to 700 persons, or maybe less than that. So there are certain parameters over which we decide that what is going to be in the future. So there should be some forecasting, and we must know our problem. Our problem parameters need to be decided, and as per our forecasting or our estimation, we think that what we need to plan today. Because what we plan today, we implement that, and with the implementation, the success we'll see at the last day when event will be happen. So several parameters are there we need to think about when we do for power system planning. And in terms of power system planning, we need to see for the transmission and distribution and generation, these are the three main parameters. We need to see that the customers, they can get the supply inadequate, and we need to forecast or accurately forecast for that. And we need to follow three basic parameters or basic constraints. Those are technical, economical, and political. Next, power system planning. What are the steps involved in power system planning? So number one, we do forecast. So by the forecasting, we come to know that what will be the power demand in the future. So that is all right, but what kind of load is connected, that is also important. We need to go for load modeling. This is also part of that. Then exploring the feasibility of generation system, what kind of generators can be installed, from where we can arrange the power to supply, and which generation will be cheaper. Suppose someone is placed at some hilly area, or maybe some other person, he may be at a location where putting the transmission line or installing the transmission line, that may be very expensive. So in that case, we can explore the areas where suppose geothermal kind of energy. We can see the solar energy. We can see the wind energy. It all depends upon what kind of generating system may be available. And at the last, things are there, but we need to optimize that. So optimizing the power plant operational characteristics, we need to see the characteristic, whether the plant characteristic, they are as per the characteristics of, excuse me, whether the plant characteristics, they are as per the required characteristic or not. We need to optimize that to follow the load. Then we need to explore of new substations. Suppose we need to expand, we know that population is increasing in the entire world. So we need to explore new substations, the requirement capacity, what capacity we are going to install, and also what will be the location. Selecting the location is also need a planned work, where to locate. We need to locate some hydroelectric power, or we need to install one nuclear power, some solar power. So what kind of power we are going to install, and how we shall send the power from that place to the customers. So whether the transmission line is possible or not, will there be heavy hazards or not? So we need to take care of those things. Then analysis of new power plants with their demands sharing. Then network expansion analysis. This is an important part because we know that many of the people who are working in the area of power system planning, they know that things are there. Everyone is getting electricity. The power is being generated. It is being transmitted. The existing power system is very, very robust. It is a very good system, but still people are researching in the planning area. People are researching in the protection area, power system protection. People are working in several aspects in digital protections. So there are several areas. If we search on IEEE or on any other journal publisher, we can see that research are coming in several areas related to power system. Though the existing power system is very robust, but we see the research is still going on and multiple papers they are coming. So we know that as the system is changing, our system is there, system is good, but what we are doing now, we are optimizing the system. For optimizing the system, we are expanding the system and optimizing the system. For these, the problems related to these aspects, papers are coming. So in the generation planning, we need to know that geographical location of the plant, type of generation, land cost. So we shall purchase the land or borrow the land as per the budget available, economical feasibility of the power distribution, placement in the center of the area of the load area. Suppose means we try to place the generating station at a place which is least is available with least distance from the customers, and it is better to place in such an area which is in the middle. But sometimes it is not available, not possible to put it in the middle. So we try to place it nearest to the customers. If the customers are distributed, so we try to search such an area which can be economical and feasible to us. Then reduction of generating cost. Several kind of generators several type of generators can be there, but which will be more economical and feasible, we search out that. Then exploration for maximum operational efficiency. We need to work on maximum operational efficiency of the plant. Then transmission planning, the main issue is economics and reliability of the transmission line. We see that all kind of transmission persons are working in the transmission system. A special group is there to keep on visiting the transmission lines to see the health of the transmission lines. We need the continuous monitoring towards that. If any of the transmission line breaks, a large part of the customers will be denied to get the electricity. So we need to continuously monitor that, and if such anything happens like that, we need to repair that or fix that at the earliest. So reliability is one thing I want to focus here. Many people of us know, but few doesn't know that power quality means how good quality of power we are getting. But power quality means वोल्टेज जो चाहिए वो वोल्टेज मिल रहा है कि नहीं, जो फ्रीक्वेंसी चाहिए मिल रहा है कि नहीं, जितना करंट चाहिए उतना ड्रॉ कर पा रहे हैं कि नहीं. दिस इज द क्वालिटी. एंड व्हाट इज रिलायबिलिटी? बिजली आ रही है कि नहीं आ रही है. ठीक है. मींस peoples are getting the electricity. Means whenever people are getting the electricity, they are getting good electricity. Means good voltage, good frequency, things are good. But 4 hours daily there is a power cut, means things are good, means power quality is good but power reliability is low. Reliability means continuity. So these things need to be taken care of, means the transmission should be continuous. Next is generation expansion patterns need to be considered. अगर जनरेशन और ट्रांसमिशन का जनरेशन और लास्ट में डिस्ट्रीब्यूशन लोड कस्टमर, इनके बीच एक बैलेंस होना बहुत जरूरी है. इफ द जनरेशन इज लो और जनरेशन इज हाई, देयर कैन बी सिवियर काइंड ऑफ प्रॉब्लम्स. सो वी शैल डिस्कस दोज काइंड ऑफ प्रॉब्लम्स. नेक्स्ट, द ट्रांसमिशन लाइन कैपेबिलिटी कैन बी इवैल्यूएटेड यूजिंग कन्वेंशनल एसी लोड फ्लो एनालिसिस. Load flow analysis, it told us the state of various power system parameters. Then consideration of economic generation scheduling, we need to schedule them so that the generators, those generators can be put in on condition that can be economical. And the second thing, generators need rest so that we can provide maintenance to them. If some of the generators, they are continuously on and on and on, so it will again increase the maintenance cost. So we need to think in that direction also. That can be achieved by proper planning. And we should take care of peak load and offload conditions. So consideration of economic generation scheduling to ensure efficient and safe operation in the condition of peak load and offload. So in case of peak load, we need to shave that. जो peak load है उसको cut करना होता है. We need to cut the peak load. We always try to escape from the peak load. We struggle with the peak load condition because in the peak condition, all the generators need to keep on, and if they are not met, there can be some problems. And this peak is not for a very long duration. So this is again a problem when this peak removes and we come to the normal load condition. So again there are certain issues. So these peaks or the engineers working in this directions, peak need to be shaved. Next is distribution planning. Distribution planning, it's part of distribution system. It has a close relation with voltage level distribution and arranging various requirement equipments. क्या चाहिए? What are the requirements at the distribution side? The instrument which we are going to install, they must be robust, reliable, strong enough. They must have good life. So they must be quality instruments. And another part is हम कह रहे हैं सब कुछ अच्छा हो. We need everything to the best, but the economy rises, means the cost rises. So we need to match the balance between the quality and the economy. Next is distribution expansion is performed step by step. Why we do it step by step? Because this is because there are certain constraints. If voltage moves up or reached up, there can be certain consequences, instability consequences. If load increases or load decreases, there can be some stability, other stability issues. So it should be done step by step. Means we are adding some generation, we are adding some load. Then we are adding up generation, then other load points are connected. So it should be step by step. Then economical expenditure need to be focused. We have already discussed this. Considering least investment and the reliability of the system already discussed. Then investigating the distribution system data and analyzing the load pattern. So this last point is very important. See that we need to investigate the distribution system data. Means who are the customers, to whom we are going to supply the power, and whether they are capable enough to pay for the supply what we are going to give. You see in India, in the rural areas, they need power to run the run pumps, water pumps, and for the lighting purpose. But about the flexible load or sensitive loads, they have very less. See the role of computers in our rural areas. Computers are sensitive load. You know that at your home or offices you use a separate UPS with that. So such kind of load, sensitive loads, even our mobile is a very sensitive load. That's why people or the experts, they suggest to use dedicated charger for them. So in rural areas we don't have, or rather we have negligible flexible sensitive load. So for that purpose, so this is the reason why we do not provide very quality power in the rural areas, and we are also restricted with the resources also, because engineers and governments, they are continuously trying to give good to the peoples, but there are certain restrictions. But in future, I think our rural areas, they will also be equipped with good and reliable quality of power. Then power system reliability. Earlier we were discussing about economy and other things. Now reliability should be there. So it is the measure to satisfy the system's load requirement. Load का requirement क्या है, उसको satisfy करना है आपको, ठीक है? And it is expressed in terms of probability function. Probability लिखना होता है. Probability in terms of what? Live power time. कितने time तक power live रही. Then environmental parameters, average failure time, average repair time. Because failure time and repair time, both the times, the customer is not getting power. For them, it is power failure. And how time you keep the power live. Then above average time varies on installing a new component or on getting a component old. So we know that with the time the things get old and the performance gets affected. So that those things need to be care of, because if we put something working, so after some time it will get damaged or not working properly, that need replacement. So money need to be invested, or we need, because this is a continuous process, because the power system is not a small thing, it is a very large area system. So this is a continuous process. We need to keep a dedicated budget for that. If a component operates as per the design aspect, the failure time reduces. This is also, अगर हम किसी चीज का अच्छे से डिजाइन करते हैं, ज़्यादा चलती है. So these are few formulas that decides the this power system reliability. In these formulas, we see that CI stands for the customer interruptions, and CMI is customer minutes interruption, means how many minutes the customer was disconnected and how many customers were disconnected. Customer interruptions and customer minutes. This is in terms of minutes CMI, and CI is in terms of customers, number of customers. So the F, R, and H, these formula can be used. Average number of service interruptions, average customer restoration time, average total interruption time, and various other. These are very standard parameters in terms of to establish the reliability or to measure the reliability. These are by the standard IEEE 1366 and 2001. So the persons or the people who are interested to work in the reliability direction, they should read these parameters. Then what are power quality issues? So reliability is one part and power quality is another part. So these there are very basic 1, 2, 3. You can see harmonic, sexual. Third one is interruption, then flicker, then transient. These 5 are the basic power quality issues. We can see a few of the researchers, they have introduced 1 or 2 parameters, but they have added 1 or 2 issues, but they are still under the standard establishment. So as per now, these 5 are the basic quality issues, and the causes and effects, they are of course related to you can see that the harmonics, electromagnetic interference from appliances, machine, radio, TVs, they work on different frequency. So various harmonics are introduced there. We know that the power generation is not purely sinusoidal. So due to design issues and the load many a times it is not linear. So that also creates problem. Harmonic creates. So and measure in the voltage as well. Okay. Suppose some short circuit is there, when some shutdown is there, or suddenly you have removed, isolated some load, or you have attached some load. So voltage X and shell, they are observed, and interruptions. You know that if some suppose some wire gets burned or some other issues like that, so some interruptions you can observe in that. These all things, the various effects you can see. Flicker, arc furnace is there. Whenever load is there, some flicker is there. Voltage fluctuations, lightning, turning measure. So these are basic things. You can see, read out these issues. You can go through the causes. This is a very good field to work in on quality. It seems that these things, they are explored very well, but in my opinion, you can still go through these. This power quality area is still had a scope to search out, so need to be researched. So this graph you can see there, you see this from 1980 to 2017. But see this horizontal or the x-axis or this year axis, this is not equally distributed. From this, see this is there is a 5 years gap. Thereafter over here you can see this 5-year gap. Over here also this is a 5-year gap. But after 2010 you see that there is 1 year gap always in each pointer, each cut. You see 1 year gap. 13, 14, 15, 16, 17. So it seems that the load was increasing. Over here we have placed this on the y-axis. This is the load axis. Net consumption in billion kilowatt hours. This is global power consumption. So it seems that it was increasing like this up to 2010. Then it fall down. But it is not the scenario. It is increasing continuously. Only the year scale is non-linear over here. You can see this is the data. If you draw it, you will find that this is linearly increasing. and in few of the countries we can see that it is drastically increased. I will take 1 minute. Aniket? Actually, there was something which was very disturbing. Okay, so we were here. So we were discussing about the global power consumption. So with this graph, I want to show that it is increasing continuously. Now, when it is increasing, it means we need to plan accordingly. We know that in the future it is going to increase. What is going to load is going to increase. So we need to think at that direction, because we can plan, we can do a good planning only if we know, only when we know that what will be the load, this power requirement of the customers or the peoples. So load forecasting, it is a vitally important tool for electric industry in the deregulated economy and electricity market. I want to tell about the term deregulated. Deregulated means earlier we have observed that only one or two government companies, they were generating the power. They were, though the distribution, that this transmission is still not too many companies are there. One established grid is being used, national grid in India. In distribution part, we can see very multiple distribution countries in India. Earlier, it wasn't the scenario, and people were forced to purchase the electricity from the company that were availing the power to the customer. But now there is a freedom. See the case of Delhi, our national capital. So the chief minister there, he says that if one of the countries, say Reliance Power is providing power there, so they are saying if Reliance will not give them good or the cheaper electricity, they will switch to some another distribution company. So now the Delhi part has that flexibility, or they have deregulated power. Same case is evolving throughout the countries, but still we do not see such kind of phenomena throughout the country. But things are evolving, and we shall see it in 10 years or 20 years. Next, it helps, the load forecasting helps an electric utility to make important decisions. Of course, a part of planning, including decisions on purchasing and generating electric power. Load forecasts are extremely important for energy suppliers, ISMEs, independent service operators, financial institutions, and other participants in electric energy generation, transmission, distribution, and market. It is an estimate of power demand at some future period. So this is important, that we need to estimate the power demand that is going to be in future, and of course that need to be based on certain facts and parameters related to the power. What can be those? Suppose if there is a huge thunder, बहुत ज़्यादा ठंडी पड़ रही है, so in case of thunder we operate with heaters. That heater consumes the power, means our requirement of electricity increases. See the case of summer, we switch on our ACs, air conditions, so that also requires large amount of power. But suppose there is a very smooth weather and some holiday is there, or the requirement, there are conditions when the power requirement is low. So if those conditions are available in the future, so we can say that the future demand will be low. So it is based on the parameters. So these are the forecasting siblings. This word I have used, siblings, means they are the synonyms, or these are the words sometimes used by the researchers in place of forecasting. So forecasting, predictions, foretell, prognosis, estimations, foresee, anticipate, guess, prophecy. So these are few terms people has been using for the forecasting. So these terms are important, and somehow in place to place these things are very also. See, the term estimation in the state estimation is another part, and this forecasting is another part. So things are a bit different, but people's working in this area, they had been using these terms. The need of accurate load forecasting. These two slides, that this is slide number 14 and 15. These two slides are important. These two slides will tell us why it is important to forecast accurately and why forecasting is important. So at the last of my lecture, these two slides will remind you, and in the long future you will remember these two slides. I will explain this. If forecasted load is lower than the real load, suppose in future the load is going to be 100 megawatt, and some engineer, they calculated today as 80 megawatt, means they are forecasting that tomorrow will be 80, but in actual tomorrow it is 100, means he is forecasting lower value. So if these things happen, what will happen? This calculation may endanger the system reliability. Means some of the part you won't be able, that particular engineer or the system won't be able to fulfill the requirement of the customer. Then to meet the unanticipated load increase, uneconomic generation or purchase of spot power might be necessary. अब ये कैसे होगा? ये see this point number 2 means that 80 you are ready with that 80 megawatt. What about the additional requirement of 20 megawatt? At that time you need to purchase that on spot, and you know that whenever we go for on spot purchase, I need this anyhow. The seller will say, no, this I will sell this, the 10 rupees thing, you will get it for 15 rupees or maybe more. So this is what is spot pricing. So that will be very expensive. This is spot power will be very expensive, means if in prior you arrange that extra 20 megawatt, it will be cheaper for you. So economically this is lossful. Then load interruptions or controls might be invoked. Of course, load interruptions means reliability is low. Then commitments to sell power may have been made at a price less than the value of that power to the utility. Means this is related to demand and supply things. You are forecasting that the demand will be low. So what will you do? You will keep your price low. Load अगर demand low है तो आप उसका price कम कर देंगे. But in actual, at the time of actual supply, you will see that due to low quote of price, several people, they will ask power from you, and you will commit them to supply the power. And as per your commitment, you have to supply them power. So this will force you to purchase the spot power to keep your commitment. So at one side you are keeping the price low, and second side you are purchasing this spot power. So you are economically at a huge loss. And the last one is too low real-time pricing might have been quoted. This we have discussed that it results in revenue falling. Your revenue will be low, overburdening the utility. Okay, so these are the points. This is simple, some calculation thing. It seems load forecasting. Some people think that these are simple calculation thing, nothing else. But the consequences may be very bad. So in between I have switched the slide. So actually I discussed slide 15 earlier. So now 14 means someone quoted higher, means 100 is the actual requirement and someone is forecasting to be 120. Then what will be the consequences? So it will be units may have been unnecessarily committed. Suppose you require for fulfilling the 100 megawatt, you need 5 units to be on. But what you are doing, you have calculated 120. So what you are doing, you are making 6 generators, 620 megawatt generators on. Means one generating unit that is unnecessarily on or unnecessarily committed. There is no requirement. And if some of the generator is unnecessarily running, unnecessarily on, so it will raise the fuel cost. And if it is on, it is running continuously, it will require maintenance also. So that cost will also increase. And then another point, expensive power may have been purchased. Now you were capable enough to suppose you were capable enough to produce 100 megawatt. But now you think that there will be a low requirement or that high requirement, so you will purchase or you will arrange extra 20 megawatt supply. So that this will be at economic loss. That overly high real-time pricing might have been quoted. This will depressing yourself. आपके price high हो जाएंगे, आपसे बिजली कोई नहीं खरीदेगा. और आपने क्या किया, एक एक्स्ट्रा जनरेटर लगा के रखा हुआ है. So this will be at loss. And this is the last point. You see this, unnecessarily interruptions or load control might be invoked. There may be control issues, there will be interruptions, annoying customers and lowering revenue. And one point is also there, if the load there is difference between the load and generation. Suppose load is less, then frequency is higher. If frequency is higher, there are stability issues. And other way around, if generation is less and load is high, then the frequency, the operational frequency will be lower. And that there will be similar kind of consequences, the stability issues will be there. So we need to think at that direction. The main problem of power system is this, that whatever requirement is there, we need to fulfill that. The generation need not to be more, need not to be less. It should be equal. Though arrangement should be there. Arrangement should be there because there are certain, because we are peoples, the environment conditions, they are non-linear. Our requirements are not very much defined. We are humans. So things are there so that therefore we need to arrange it. So always keep these things into mind, that why proper or accurate forecasting is important. Because it is the first part of your planning. आपको पता ही नहीं है अगर कि शादी में कितने लोग आने वाले हैं, किसकी शादी होने वाली है, क्या अरेंजमेंट्स करने वाले होंगे. When you don't know these starting information, what is going to be, you cannot make a good or make a proper planning. So that is the very first part. So this is the first part of your research, the forecasting. And you see that in a few of the economical research, I have noted this point. Then an increase in power estimate of 1%, it may cause a 75 crore Indian rupee additional cost in operation and installation. This research has been done for a larger area of power system. Even 1%, it may result in 75 crores. See how important is the accurate load forecasting. Then forecasting requirements means we need to perform the load survey, load extrapolation, mathematical modeling, energy consumption curve. So these things we can perform to know the forecasting. Means by what will be the load, we can survey the load, we can prepare some forms, we can take the opinion of the customers, we can see that if some industry is going to be established or what kind of customer can be there. Then load extrapolation. Sometimes if some existing part is there, we need to know the future load. So from the earlier graph, we can extrapolate the future points. Mathematical modeling can also provide the future load. If you know the parameters of the load, then also the mathematical modeling, but it needs to be accurate. Then energy consumption curve. Of course, this is similar to this load extrapolation. So this energy consumption curve means what has been consumed in the past. From that also, we can have some certain amount of good forecasting, but that need to be mathematically investigated. Then factors affecting the load forecasting, similarity parameters means you can see that on Saturdays, Sundays, these are the off times. People are at home, they are rest, they take rest. It means on the rest periods, people don't work, the industry of the industries, they are off. So the requirement of power is less. You can see the commercial markets. Suppose at many of the places, Tuesday market is off. So that commercial load is decreased. See the meteorological parameters. Mausam Vigyan wale jo parameter. Temperature is increasing, decreasing, humidity increasing, decreasing. See atmospheric pressure, cloud cover, rainfall, whatever is that. We always think in the direction that whenever things are normal or the environmental is normal, the requirement of power is less. Whenever there is deviation in the power, then load requirement increases. Temperature here is high, load will increase. Temperature is less, load will decrease. Then demographic parameters, type of locality. आप देख रहे हैं कोई कह रहे हैं पॉश इलाका है, कहीं पे क्या कहते हैं ज्यादा अमीर लोग रहते हैं. So those rich peoples, they will have various kind of luxury requirements. ठीक है? So for those kind of requirements, they will consume more power. कहीं पे आप देख रहे हैं farmers रह रहे हैं in villages. So that is different kind of demography. They will consume less power. They have different kind of consume customers. Then economic parameter, class of customer, income of the, किसी के पास ज्यादा पैसा है वो खर्च कर रहा है, भाई एक जना है. There can be one user who is keeping one AC in one hall only, and people are sleeping in that one hall. And someone who is rich, who is having very heavy income, they have installed ACs in each of their room. So it depends on the type of customer or the income, also their lifestyle, what are the places. Then various electric load forecasting models. We can see that there are statistical, mathematical model. Some statistical techniques are there. Time series forecasting model. They are very, very popular methods. They are still being used and they are considered as more. Is the time okay? I am having the time. So there are these time series models. They are very reliable, and they are still considered to be reliable. And these are being used in the industries. Still being used. Though we in research papers we study AI-based model, neural, fuzzy, and these or that, we read several things. But people are still, the industrial people, they are working with time series forecasting models. There are other models also. I want to skip this: end user model, econometric model, AI-based model, hybrid models. This is basic artificial neural network. I will explain that this is the input layer, hidden layer, output layer. The inputs coming to the input layer first, then it transfer to the hidden layer. Then these the output of hidden layer transfer to the output layer, and this layer provides you the output. The input coming from the input layer, it doesn't go to this output layer directly, but it gets multiplied by some weights. This W, each connection has its own weight. It may be different, and in most of the time they are different as per the system requirement. So of course, see, this A represents artificial. Actual neural network is in the human brain. So this is artificially we trying to replicate that reflects the input-output relationship. These are the output, these are the input. So input-output relation can be seen by this mathematical equation. You can see in any of the basic this neural network book. See, Simon Hacken has written one book. So that is very popular for this neural network study. So those who are interested in study these particular topics, they can go through. So what is the role of ANN in ALF? So means what is the expertise of this ANN for dealing with ELF model? So they are fault tolerant. बहुत सारे connections, they are massively connected. If one or two connections they are dead, even then it keep working good. So they are massively connected, so it provide good output even in the case of failure of certain connections, or few connections. Parallel data processing means data is processed parallelly. One direction, at one of the connection, data is being calculated in few of the neurons, and at the second side, other neurons they are calculating. Means parallel processing is there, so they are capable to calculating at a faster rate. Then ability to learn. What is the meaning of learning? Learning means you are deciding the value of weights. Those weights I have recently discussed. So you need to identify the proper value of those weights. If that weight is proper weight are identified, then you can say that your neural network is well trained. So that training is an important part, and it can also handle large amount of data. And this large amount of data will help it to train for proper training. Then it has black box nature. You need in any kind of most of the modeling, you need not to know that what are those parameters, what are the supporting parameters. But here you need not to remember the weights. Weights are there in the within that black box or the neural network box. You need not take care of that. Then does not require any design knowledge. Normally they are taken care of hit and try, and several other pruning and development techniques are there for making this neural network structure. Then it is robust to tackle the noise present. आप देखते होंगे हमारा जो फीचर है हमारे ब्रेन का, हम किसी धुंधली पिक्चर को देख के भी अंदाजा लगा लेते हैं सही किया है. So as we can identify a blurred image, the person from a blurred image, that no, this is that person. So similarly, that kind of role is that attribute is there in the artificial neural network. And the last one is it is easy to reconfigure. Means the weights are there. If some new parameters are there, means some new examples are there for the neural network to get trained. So it can take those new inputs and it can modify the weights of the neural network. Then ANN parameters means what are the layers, number of layers, neurons, hidden layers, what are the activation functions. Activation function, every neuron has its activation function. It decides the relationship between its output and its input. So if it is a linear one, means only linear relations can be established. So in most of the cases, activation function is non-linear, because a neural network, we know that most of the times it is used to establish the non-linear relationship, or the relationship which is not easy enough to be established by the by simple mathematical functions. In those cases, we use this artificial neural network. Then training parameters means which training method need to be used, or what will be the speed. This need to be taken care of. So there are in general three, mostly this is the supervised training algorithm. So a system is there. So from the system we take up the data, and this data goes to ANN, and it gives you certain output. And if the output is correct, the teacher said the output is correct or not. So the difference of this is the error. This error moves to the ANN, and it changes the weights of ANN. So this ANN learns. This way ANN learns. This is supervised because this ANN is being supervised by this teacher, whether the output is correct or not. It is providing the signal. Then there are certain conditions when there is no teacher, but based upon the system, this ANN decide where some output is correct or not by certain adaptation rule. Okay. Suppose you are looking that something is happening again and again. Something is when something is normal or happening in the same way all the time, then you will say that this is correct. If something happens, suppose some apple always came down to the earth. Suppose in any event that apple is going up, what will you say? No, this is wrong. So this is by certain adaptation rule. Means some apple will come down due to Earth's gravitational force. So there may be it depends upon system to system, problem to problem. So ANN learns by various adaptation rules, and those rules they can be tracked by the ANN itself and based upon the system properties. So this is unsupervised learning, and another is reinforced learning. Means when output is coming wrong, the weights they are penalized. Okay, there is some mistake in this. Okay, so reinforced learning means if some output is wrong, the weights will be penalized, and means they will be reduced. And if there is bad output, means when there is in minus direction or plus direction, there is change in the error. So at one side the weights are pruned or penalized, but at the another side weights are developed or added. So this is by the reinforcing. Over here it is there. Then this is Levenberg-Marquardt training algorithm. One book I have discussed that was Simon Hackin. In that is very good book for learning this neural network. So this you can see, this is the algorithm, one kind of back propagation training algorithm. This is being used to train the neural network. It is faster, but it consumes a lot of memory. In nowadays there are several other techniques, various kind of neural networks are there, and LSTM technique is there. So several things are being used, but you need to, whenever you start the work, you need to start from this point. So this is available in that book, this algorithm. I'm skipping this. So what is the ideal forecasting model? Of course it should be adaptive, recursive, computationally economic, then robust and accurate. Then model-based classification of electric load forecasting model. The similar slide I have already discussed, so I'm skipping this. These are various points how the evolution of this load forecasting model. So it is seen in 1918 first, and Box and Jenkins models, they got very popular. They are still popular. They were developed in 1960. Then state estimation based models, they came in 1970. In 1990s, ANN based models were introduced, and they are still on. People are still working on these models. Fuzzy models, they are still being researched. But these two models, there are certain disadvantages, and few other models they were also developed, but there were several as a sole model. We see various or few lags in the model, so we prefer hybrid kind of models where we provide optimization also. So with the optimization, we see good forecasting and good operation of the model. And then about the implementation, I think the time do not permit me for this, and also I'm engaged somewhere, so I will take up this at some other platform. So this is my contact. You can contact me at this email ID related to this lecture. So I thank you all. If any query is there, please ask me.
Yes, any query from the participants? There were, I think, in the chat box, no articulated, great insights. Okay. Yes, any query from the audience, from the participants? We can take 2-3 questions if there is any, or you can directly write to Dr. Navneet sir. Mona, are you there?
Yes, sir.
Okay, please carry on.
Thank you, sir, for enriching us with your valuable words and in esteemed presence. Also, I would like to thank all participants. Now, with this session is over. After a short break, Expert Talk 8 will be start at sharp 5 p.m. IST. Thank you so much.
So, with your words, Manna, I wish to thank to all the organizers who has invited me for this particular lecture, and I wish I want to provide my best wishes for your course, and all my listeners who has listened this lecture. I want to thank them also, and all the best for your future. Thank you all.
Thank you so much, sir, for your time and efforts. It was really a nice interaction, and thank you. Sir, if possible, please provide us the PPTs as well.
Okay.
Thank you, sir. Next session will start within a few minutes. So till then, let me share the feedback panel.
Sir, kindly share the feedback link for this session.
Ramana, are you there?
Yes, sir.
Okay. After some time, after 2-3 minutes, she'll join.
Okay. Okay.
Hello, Jitendra, am I audible? Yeah, your voice is not
Ma'am,
audible.
you are audible.
Yes,
Yeah,
ma'am.
Ma'am, you are audible. Good evening, ma'am.
Good evening.
How are
Good
you,
evening.
ma'am?
Ma'am, आप कैसे हैं?
I am fine. I'm fine. How are you? Hari, and you all?
Yeah, fine, ma'am.
Okay.
Okay.
Ma'am, Ramana, you can start now.
Ramana, are you listening?
Okay, sir. Okay, sir. Good evening to all and all. Welcome to the online short-term course on Recent Trends in Microgrid 2020. We now have expert talk 8 to be delivered by Dr. Premalata Jena ma'am, Associate Professor at the Department of Electrical Engineering, IIT Roorkee, Uttarakhand. Dr. Premalata Jena ma'am has received her BTech degree in Electrical Engineering from the Utkal University, Bhubaneswar in 2001. MTech degree in Electrical Engineering from IIT Kharagpur in 2006 and PhD degree from IIT Kharagpur in 2011. She has 7 years teaching experience. She is IEEE member and INAE Young Associate. She received many awards such as Women's Excellent Award, Early Career Award under SERB, DST Government of India, New Delhi, INAE Young Engineer Award, POSOCO Power System Award in 2013. She has published many papers in different reputed journals and conferences. Her field of interest are smart grid technology and production, microgrid production, signal processing application to power system relaying, power system protection issues with fax devices, protection schemes developed for line with the fax devices, disturbance location, signal processing application for disturbance location. If I speak further about Dr. Premalata Jena ma'am, this session would not be enough. Hence, I would like ma'am to take this session and enlighten us. Dr. Premalata Jena ma'am, please.
Yeah, so thank you, Ramana. And really, it is not required. This initial recognition and all, this address is not required for me. I am not that much kind of like achievement. It's not a very big achievement. So anyway, so thank you for this nice introduction. And okay, so today I'll just try my best to share something with all of you from smart grid area, like what is smart grid, what is microgrid, and there are many production challenges, but I'll try my best. A few of it I'll just put in front of you. And I have been allotted 1 hour time, if I'm not wrong. So 5 to 6, already it is 5. So I'll just try my best. And further, if you have some, clarification or some contacts you need, you're most welcome every time. Okay, so shall I start, Jitendra?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Thank you so much.
Okay. Ma'am, please.
So I'm really thankful to Om Hari and Jitendra. They have arranged this wonderful session. So let us try. I put my best effort. So let me share my PPT. Okay?
Please share, ma'am.
Yeah. Just a minute. Huh?
Yeah, ma'am.
Now is it visible?
No, ma'am. Now it is.
Yes, ma'am. It's good.
Yeah, it is visible, right?
Yeah, ma'am.
Okay. Yeah. Oh, sorry. So there was some issue in the network actually here. So therefore, it was actually creating problem. So anyway, so my PPT is visible to all of you?
No, ma'am.
Okay, it is not. Is it visible now?
Ma'am,
Yes.
there is.
Is it visible now?
Not yet. Yes, yes.
Yeah.
Okay. So anyway, so thank you to all the participants, and really it is actually a honor to be with all of you. And the topic. So what you can see in my it's really really a great interesting topic, I can say. So when I started my journey in this regard, smart grid, it was quite cumbersome, like how to start. But once when I started it, so I found that this is interesting, and we can do so lot many things regarding this topic, and we can do lot many research, very interesting things we can do. Fine. So as you can see, sorry, one problem is coming. I could not go to the PPT. Is there an issue with this Google Meet?
Yes, Doctor.
Yeah.
Yes. Can you please reshare the screen? Can you reshare? Now it's okay.
Yeah. So fine. So as the first PPT I just wrote, it is smart grid is a vision or service. So this kind of point should be discussed. Many times we think that this smart grid is basically it's a kind of product. So wherever you can deliver, it will go and it just plug in and plug out. So it will just work out. So it's not like that. So it is a kind of really it is a vision. So finally, when things we'll discuss, you can know that it's a very important tool and important topic or technology or era, you can say. So which is actually really a vision. So that is what I'm trying to inform to all of you, and you'll also be agreed with this point. So before that, I'll just give a very small glance on the power market, power scenario of India and the globe as a whole. And so then we will be, understanding that why this smart grid technology is very essential for all of us. The first point that you can see here, the green one is your renewable sources, and this brown one is your fossil fuel based generation systems. So this fossil fuel based generation system is almost around 55.4%. It's a very big number, So we have to reduce this generation, and we'll try to achieve as much as possible to extract power from the renewable sources. So as all of you know that the renewable sources are very intermittent in nature, and it is very difficult to accommodate in the existing network. But however, at the same time, the coal-based generation system is also, it is running. The depletion rate is very large. It is going down, and maybe it is also predicted next 20-30 years. Maybe it will be just in a zero position. So what is next? And even then, it is available. Suppose it is available. So its reaction, like carbon dioxide emission process, is so harsh. You can see that pollution level is very high, today's date. So therefore, the main driving force for all of us is the renewable source. And this renewable source is actually present scenario in India, it is very less. And we are trying to make, I'll share with you some of the initiatives taken by the government of India and many IITs and NITs also, many institutions are trying to do how to cooperate the renewable source agencies, and how to encourage the customers to buy and purchase power from the renewable based generation stations. So that these are some of the key points, and from where the driving force and driving points come forward towards a smart grid technology pathway. Right. So now this is regarding the renewable source installed capacity in India. Today's state, if you see, renewable source capacity, installed capacity, 87.02 gigawatt. Right. So you can see previous slide, it is total generation installed capacity in India is 370.106 gigawatt. But if you see just renewable source, it is 87.02 gigawatt. So now out of it, this wind power is almost 45.2% and solar is 36.7%. So the point is here, the major sources like solar and wind, which are actually our backbone for the renewable sources. And those are really in India, if you see, the solar is some major backbone of renewable sources, and then wind comes. But however, now the progress is going on. So how we can motivate, we can promote the solar integration, rooftop solar integration in India to a large extent. And it is also in the process. The government of India, there is a wing, MNNIT, that is the Ministry of New Renewable Energy source wing from the government of India. They're taking off how the renewable sources can be, prolifered throughout the India to a large extent. And it should occupy the maximum pie chart, instead of the fossil fuel-based generation systems. So these are some of the key points we should keep in eye, that before going to why we are so much worried for the smart grid technology, why we are so much worried for the microgrid technology. And coming to this world energy scenario, like world installed power generation capacity, which is basically forecasted, it goes in a very exponential manner. If you see this picture, it goes in a very exponential manner, right? So this is not a very very steady, slowly it is increasing. No, that means our demand by 2029, the demand is quite large. It is increasing exponentially. So in that case, what happens if your demand is quite large? So our supply should be in that way. If the supply, if we are just taking from the fossil fuel-based generation system, then of course we are going to lose everything. I mean, there will be a very great imbalance in the ecosystem, right? So in that way, we have to definitely concentrate on the renewable sources, right? So that and this is a sure shot, it's not a it is predicted, and of course it is predicted based on the present scenario and demands, and it's a real fact also, right? So now if you see, just quickly I'll touch here that solar energy scenario, the first country is China. It's contributing around 26% United States, second, and India is the third position, right? So India is it is in a better position. And if we'll just try our best, then with good technology, smart grid technology and other advanced power electronics devices, control strategy, maybe we can jump to first position. So that is what India is trying. And in wind also, it is also not far away. Like India is also fourth position. The first is China, then United States, Germany, and then third India, fourth India. So what I'm trying to say, so these two major renewable source backbones where the India stands, its position is quite good. Pretty good. So we have to basically empower our system, our technology, so that we can jump to higher, and so that we should not exploit the power from the fossil fuel-based generating stations. We should avoid that, right? And second, we should try to access more power from the renewable sources like solar and wind, maybe to some extent, small hydropower plants, and of course we have large hydropower plants. And those, large hydropower plants are already. I'll just talk about what are the merits and demerits. Slowly, you can understand that what is the need of smart grid and what is the need of microgrid. So now, presently, I'm emphasizing to all of you that we need definitely the renewable source as the best. Not the alternative. That should be our thirsty, area. That should be our prime goal, from where maximum energy can be extracted. Anyway, so next, this is a very interesting thing. I've shared with the students, and many forum also I discussed. By this 2020 50, it's this. If you could see my slide very clearly, I can make it in full slide form. This EIA is basically International Energy Outlook by 2019. And here there was a study, okay? The study says like this: OECD is the Organization for Economic Cooperation and Development. So this EIA has done a very wonderful study, and they have divided all the countries over the globe under two categories. The first one is non-OECD category of the countries, and other one is the OECD. So what is this meaning of this? That means they have analyzed that the country which are actually falling in the thrust area where real advancement is required for smart grid renewable source penetration, and those areas are nothing, that is Asia. And out of Asia, again, it is emphasized that India is one of the topmost point, and those countries actually the thrust area, and more research, more implementation, more market, more benefit. Implementation is basically as great field you can see from Indian context. Okay, Asia, and from Asia you can see India. Now, and like this, Americas and Europe and Middle East and other countries, like they are constant. Here you can see this yellow and the blue green lines. This is constant. Their projection is very less. But however, in Asia, this projection is quite increasing in a tremendous manner up to 2050. So that is how we are planning. Our vision should be. Therefore, I start my topic from beginning, that smart grid vision. So our vision should be in such a way that what could be our possible ways out, the map we have to fulfill our requirement. And this is actually the real study. Now, so these are some of the motivations I put in front of you is somebody ask you why we are so much worried for this smart grid technology. What is microgrid? Why we are so much worried? So these are some of my motivation I have kept in front of you. First of all, we have to reduce the carbon dioxide emission and reduction of global warming. Then peak energy deficient. So when we have a peak energy demand, so we have to supply that demand from the renewable sources quickly. Okay, so and fortunately in India, I can show you some maps I kept after this, that we have many potential areas as far as solar and wind is concerned, right? So the key renewable sources in India are wind and solar. So in that context, the India government is planning to install around 100 gigawatt of solar and 75 gigawatt of wind by 2029. And this figure is it's fine, but now I can give you one more figure. Recently, by 2030, the India government is trying to implement around 300 gigawatt renewable sources. Just imagine. So that it will happen. I'm sure that it will happen, because if we go in this manner, okay, the research and the discussion and the teaching and the industry, so everybody will cooperate in this manner. So definitely we can achieve our goal quickly. So along with that, one more key point also there, 2 points I'll discuss with you mostly. Just now I'm talking about I'm not going directly to the smart grid definition. Rather, I'm saying what are the motivation factors for us so that we will be, overwhelmed to talk about and to do research and do some, active work in this direction. Right. So this is how this, some kind of figure I have collected on REC. Renewable energy source in India installed by 31st April 2020, and here you can see small hydro is around this much, and wind and some of the waste to energy capacity, power cogeneration, this is biopower and solar. So together it comes around 87.38 gigawatt. So this is how, what I'm trying to say, India has a great capacity to access power from solar, wind, and also the cogeneration and biogen facilities. But however, our major sources are solar, and then wind comes. Now, as you know, another motivation just I'm trying to put in front of you, you'll be happy with knowing that also, that why really this field is really required or not. So this electrical sector, if you see the network, it's a very complicated man-made system, and it is very complex also. So when we are going to penetrate, and we're targeting 30 to 50% penetration. See, if 100% penetration, you think about it, it is very difficult. But up to 30 to 40% penetration renewables also a question today. So our technology should be so strong, so smart, and it should not, I'm talking about the renewable penetration, so that our existing infrastructure will withstand, and maybe we have to modify it, and maybe we have to embed some new technology, and that is what is a smart grid technology. Okay, so to have this again, so what I'll just talk to you. It's a very interesting fact. What is, some of you may ask me question, what is the demerit in the existing conventional network? And why we are going for smart grid network? What is the meaning of smart, right? So now I'll just put in front of you quickly 3 points. The first one is that in the conventional grid, no real-time communication and information flow between generators and consumers. So it is because now if you see our generating stations are like 2,000 kilometers away from the load centers. So when these loads are just far away from 2,000 kilometers from the generating stations, so obviously there is, the proper communication infrastructure is not there, and there is no information flow from the consumer sides to the generating station. It is obvious. And second point is that and supply and demand balance is achieved in real time by adjusting only the supply side. Load, see, the customers, you'll also be, all of you will be agreed with me. If any change, any outage happens, like, shut down, some kind of load shedding, it occurs in a remote areas of some village. Is it possible that your, the generating station people will reach to you and they'll correct your problems? They will just check your problems? No, it is not possible. Maybe hours to hour, this shutdown will carry on. And sometimes it happened like that that, if the transformer is burned and some lines are down, something had happened, collapsed, then it will take also months time, so to just correct it. So this is a very pathetic situation, and that should not happen anymore. In this regard, actually, there is actually lot many progress is going on at the center level, but when it is coming to the true fact field level, it is, not happening. So that is what this massive movement is required. How your, remote electrification can be done through the smart grid technology or microgrid technology. That should be our prime goal. So next is the demand side control is almost non-existent. That is what demand side control means. The customer, the generating station, the utilities, they don't have any control over the customers. Okay, so that is what is, and second, the other 2 points I just want to add, there is no large scale storage present in the existing grid. And again, the power flow is unidirectional, right? So it goes from the straightforward, from the generating station to the load centers. The load centers, they don't have any, facility or some ways out to take power or to, to serve power from their side. So they have to receive the power, that's all. So these are kind of, conventional therapy, conventional strategy should be changed. That is the first point. So one more point I just want to share with all of you, that the blackout is one of the major situation, though it is it occurs. See, actually, when the blackout is, I hope all of you know this word, but let me tell you, the blackout is nothing. It's the shutdown of the DGs, your generators and loads, and totally the circuit is collapsed. The network is collapsed, right? So, a layman to you, right? So it had happened in July 2012, in India, right? In 2016 also it had happened, one blackout in Australia also. So there are many history as the blackout is concerned. But the point is how to restrict this major disturbances. Due to this, when this July 2012, this blackout had happened, how it had happened, basically, there was a 400 kV line, which was actually connecting Jena to Gwalior, 400 kV double circuit line. So, it was a 400 kV line. It was carrying the power from western grid to northern grid. But due to the overdraw of power, this problem is known as overdraw, means one of the distance relay, zone 3 has been maloperated, and that problem is known as load encroachment problem. So this load, due to the overdrawing of the power, due to the low increase in load, demand in the other side, the protection unit has been tripped unnecessarily, and that line has been tripped. So suddenly what happened? Other lines are overloaded, and slowly other lines are overloaded, and finally the circuit was collapsed. The lines are disconnected, and one national grid has been disconnected from the other national grid. And as a result, they have to shut down the generators on the other side. Okay, so in that way, what happens? The total northern grid and northeast grid two together, collapsed, and finally, lot many critical loads, lot many non-critical loads, priority loads, non-priority loads, all, they have to shut down. They are out of service. But fortunately, I can share with all of you that the Delhi Metro and the airport, which are actually the priority loads, many emergent medical centers, data centers, which are very essential for life-saving kind of thing. So in that case, they have saved it by making islanded scenario and by supplying the backup, so the diesel gen sets or maybe some storage devices, batteries. So that is what, so this technology should be more prominent with time so that we can save such kind of disturbances, right? And also we can predict also beforehand so that it should not happen. So it can take the life also. It's not only money, it's not a cost affair, it's also life affair, right? So this is how the things actually motivate, this is how there are many task force, the task force, they just went behind what are the reasons that blackout had happened, lack of communication among operators, weak points in protection system, need more regulatory works, and lack of investment into the grid, so many, and pressures on the existing grid. The grid lines are just operating close to their limits. So those kind of situations should not arise. So that is why this smart grid technology is coming up slowly to mitigate these problems. So this is the last slide I'll just share with all of you. You will be convinced that why this large scale AC systems are not recommended nowadays. Okay, so now if you see this right side figure, that in the x-axis we have size of interconnected grid, and y-axis we have benefit and efforts. If the size of an interconnected grid is just you're starting it, so it is say in the middle of it is little bit optimum, and you have less effort, more benefits. Okay, this red one is the effort and the blue one is the benefit. So now if you just move ahead further, if you increase the size of the grid, in the sense you can either distance wise or power capacity of the lines wise, size you can say in any manner. So in that case, what will happen? Even though you put more effort, even you can see my cursor, even then your benefits are less. Okay, so therefore we need a very judicious, cunningly, some system. So that today's date, this kind of system is not, the researchers and maybe industry people, they're feeling that advantages diminish. In the synchronous system is very large. And there are so many other issues also here it is written. Long distance transmission system has voltage stability issue, reactive power problems, steady state stability, transient stability, oscillations. Interconnect system has problem like load flow problems, frequency control, voltage stability, oscillation, so many things are there. Okay, so this blackout risk due to the cascading effects, just I discussed with all of you. So these are some of the very thought process we should think about it before starting any subject. See, I always tell in my many forum also, like, why I'm doing this? What is the need of this technology and what is the need of this topic? What's the need of spending more time on this? So these are some of the thought process I just need to share with all of you why we are interested for smart grid. Okay, so this is how this pressure is on the present grid, and we need some flexible grid, and that grid will help us to provide a very flexibility, customer side or maybe utility side. We have to reduce the gap between the customer and the utility. So I'm coming to the point, track point, right point. So where the customer can quickly access the utility and the utility can quickly access the customer, right? So that should be the gap. And nobody should say that I am the master, you are the servant. So all are in equal platform. The customer has equal right and the utility has also equal right. Both are in the same platform. So that way what will happen, that this outage like efficiency, reliability, security, sustainability, every aspect of this supply, electric supply will increase. Okay, so that is quite possible if your grid is flexible. Our grid codes regulations are flexible. Yeah, of course it needs so many technology. I'm not denying for that, but obviously, and it is very, of course, we need some flexibility in the existing grid. And the grid is now pressurized due to the huge demand and lack of fossil fuel-based generation. And of course, we are penetrating this renewable sources without knowing anything. We don't know any ABCD, but I'll just put on solar. How is it possible? Our network will collapse. So we need to understand where it will be penetrated, how it will be penetrated, then only it will work properly for us. And that education is present in smart grid technology. And if you learn it, then we can understand how to handle this situation. So these are some of the drivers for change. So electricity consumption growth is increasing, aging infrastructure of our Indian electric system, and increasing cost of energy, evolution of the, let me tell you how this cost of energy is increasing. In case of diesel generator, if you run, it will be cost around maybe rupees 20, 10, 30 something sometimes if it's very emergent. But if you use a solar based generation, maybe 2 rupees 3 per kilowatt hour, maybe 4 rupees 4, like this. So we have to see that aspect also. Okay, so as we are developing country, so energy security, users expectations, technological advances. I'll share with one of the aspect what is the users. There's so many aspects, but I can share with all of you one of the aspects very quickly in one of my PPT. And of course, to accommodate the intermittent renewable sources. So that means we have many things in front of us. So if you're going to accommodate all these aspects together you want, so one solution can be derived from this smart grid technology. So coming, I hope that all of you are agreed with me that with this, all these motivational points that recently, I'll just come quickly that what is smart grid? Very in small line, I can tell to you by collecting so many definitions are given like Wikipedia, Global Smart Grid Federation, Energy Department of USA, so many things are there. Energy Future Coalition, so many people, organization, they have given definitions. The simplified way, I can tell you, the smart grid refers an electric transmission distribution system that incorporates elements of information technology, communication, that is known as ICT technology, to provide better grid performance and to support a wide area of traditional digital age service to the customers. So in simple form, the right side, let us say you have the right side, you have the existing grid. Nobody is denying the existing grid. On the left side, you have a very good information technology, communication, dedicated communication technology. You have advanced, sensors, and at the same time, I have written here. You can summarize and write. Like you should have like a adaptive dynamic control strategy. So together, if you just these two things, right side is existing grid, and you have this side, you have information technology, communication technology, you have advanced metering infrastructures like sensors and dynamic and adaptive controllers. So when they marry together, then there is the rise of smart grid. There's a generation of smart grid. The smart grid is nothing very new, or it's not very big thing, or it's not a very very challenging aspect also. When these two things you merge together, so that brings the idea of smart grid. So smart grid indirectly, it needs a very dedicated information technology, communication infrastructure, and of course first sensors, and you have advanced controlling infrastructures, everything, so that I can control automatically what is happening in my network. And as a result, what will happen, and this intelligently I can control my loads, my generation, my every aspect I can guard. If there is a monitoring or a communication infrastructure, I can guard, I can just visualize what is happening at every aspect, every corner of my network. And as a result, we can move towards a sustainable, economic, and secure electric supply network. And most importantly, we should, there is a actual data I can share with all of you. With this transmission of power from a load, generating station to the load center, we are losing like 20% loss. If my generation will be close to my load centers, so I can just stop this 20% loss very easily. So in that case, and there's so many other advantages, like if my solar park, one of the solar park is close to my load centers, and that particular customer can easily access those utilities, and they can speak to each other through their advanced metering infrastructure, control, or communication strategy. Okay, and now it is also happening that so many in buildings, there is a rooftop mounted solar system, and if they have some surplus power, they can also deliver to the grid also. Okay, so to the grid they can also deliver, and the grid can also deliver the power to the utility, and the utility also, customer, and the customer can also supply some power to the utility. It's quite amazing. So that means it's a two-way power flow now, two-way power flow and two-way information exchange. So everything is possible in smart grid network, smart grid area. So that is what is now the thrust area to understand how it is possible. Just by saying the definition, it is not possible. So we have to realize in practical system. We have to realize in practical field, and how is it possible. So that is what is nowadays it is going on. So these are some of the features and visions. As I said, my topic was like that. None of these definitions convey clear and complete understanding of smart grid. But smart grid is not a product or service somebody will give you. It's just like a adapter, just like a keep your near to your refrigerator, like regulator. It will just boost the voltage. It is not like that. It is a vision. So what kind of technology will suit to my the infrastructure, and this problem, how it can be solved. So that is what it is, a vision. It's not a product. Slowly we have to develop it. Okay. So anyway, so this is how my this topic goes: smart grid why this I just discussed with all of you, why this smart grid is, first I motivated to all of you and the way I have been motivated when I started this topic. And then I just tried to inform you that what is a smart grid in a very layman word. So now I'll tell you very in a simplified way the three things I'll share with you. What is microgrid, what is mini grid, and what is nanogrid. And you may be astonished that quickly from smart grid, this topic, what is the relationship between these two? Yes, it has a relationship. So if you just go back before 2 minutes, I said with all of you that there is a loss of 20% when I'm just transferring the power from a 2,000 kilometer away from generating station to the load center. I'm losing some power losses. Why should I do that? Why not this renewable sources of storage, whatever I'm just trapping? It should be near to my renewable source, near to my customers. So this kind of small grids together is called as microgrid. So this micro means 10 to the power minus 6. And this giga, if I started my talk like with our installed capacity of India is in the range of gigawatt. Giga means 10 to minus 9 if I'm not wrong. So if you multiply, plus 9. So if you multiply this micro with nano, giga, so you'll get 10 to the minus 3 watt. That means 10 to 3 watt. So that means you are getting kilowatt range of handling capacity of the grid. So when this grid was handling gigawatt of power, so we are just scaling down to a lower level, that is kilowatt range. Or maybe some kind of according to IEEE standard. So we have IEEE standard 1547 IEEE standard, which is basically designed from IEEE for dealing with the standards of microgrid management, interfacing of the electronic devices, converters to the grid, AC grids. Okay, so there you can see that microgrid can handle up to 50 megawatt. And nowadays also I came to know from one discussion forum, it can go also up to 100 megawatt. So that means with a small package of power, let us some kilowatt, some megawatt, 10 megawatt, 2 megawatt. In IIT Roorkee also, I'm just declaring in front of you, we have the peak demand is almost, the installed capacity is up to 8 megawatt. So we are getting around 2 megawatt, 1.8, 2 megawatt from the rooftop mounted solar. And it behaves as small, it's not a microgrid, but the microgrid, I'll tell you what is that. So a small package of power I can utilize just near to my door of my customers. So when all together the microgrids, many microgrids are connected together, so it forms the smart grid. It is very simple. So we can reduce in that process, we'll have many benefits, several benefits, advantages. So that is what is the key point of microgrid. It is the cornerstone, the minimum smallest unit, small unit of the smart grid. Okay. So what is the definition? We will not go by definition. I'll just tell you in simplified way. The combination of the renewable sources we have, and definitely see somebody says distributed energy resources means it includes renewable sources as well as your storage. Okay, so renewable sources as well as the storage. So when somebody tells that renewable energy resources means it includes your renewable sources like solar, wind, biomass, fuel cell, small hydropower plants. So along with that, storage should be there. Then only it will be called as distributed energy resources. And when this network, certain network has this renewable sources, storage, some loads, and it is connected to the grid. And also it can operate in a grid connected mode or it can operate also islanded mode. Okay, so that kind of environment is known as microgrid. What I'm trying to say, the microgrid is connected to the grid and also it can operate independently. And that is known as islanded mode of operation. Okay, this is how this microgrid goes. And what is mini grid? The mini grid is this mini word itself stands, it goes up to 15 megawatt and the voltage level is almost 11 kV, okay, or less than that. And you can see here this picture, this mini grid is nothing in South Africa. Most of the remote villages, basically, they have small cluster villages where a small, solar park is there. From there, just they're supplying 4, 5, 10 villages, maybe 2 villages and some few households. And here you can see the solar photovoltaic, and then you have inverter. Then you have the step-up transformer. Of course, this is step-up transformer. because this village areas, maybe sometimes you can also take it 11 kV or some more less than that, 4.12 kV also, and some agricultural processing loads and some residences. So that you can see quickly that mini grid and micro difference is what? Mini grid, there is no grid connectivity, but in microgrid the grid connectivity was there. Okay, so this mini grid is free from the main grid, and of course the power supply is not so much reliable, because when the storage, solar is not there. But of course one thing is guaranteed: nothing is possible if in one area at least for 8 hours, 10 hours they'll get the supply. Okay, so this is how this mini grid is different from microgrid. And this nano grid comes a small building. Suppose our building. So there I can tap, like, a particular building or some tower can take some power of one house itself, can consume 500 watt, 400 watt, whatever. So in that range, the nano grid is a small building which can be properly decorated with a smart grid technology, which will act as a nano grid concept. And when this nano grid is the smallest unit and many nano grids are connected together, it comes as a microgrid, and many microgrids are connected together, it forms the smart grid. So I think now you understand what is the meaning of microgrid, right? So this is how it goes, definitions, and I'll not cover up this because due to the time constraints. So sorry. So quickly, I'll just come one protection concept, because there are so many protection issues. So you may heard me last 40 minutes. Maybe, more than that. So I talk about very good aspects of the smart grid. But at the same time, if you are going to enjoy the advantages of the smart grid technology or renewable penetration, we are going to avoid blackout, we are going to avoid fossil fuel-based generation. But at the same time, so many issues are going to arise, isn't it? So the first issue, in my opinion, what I am just dealing with in research, protection issue. Another one, stability issue, inertia concept, virtual inertia concept. There is a great need of, like, this is fault right to technology. Then you should have some power quality issues, and then you should have to, like, we have to design a very good converter, like, solar and wind, fossil fuel, battery. The part of this. These are the components of the smart grid or microgrid or nanogrid, whatever. So controllers. So they need a very good design. Power electronics devices, and along with that, they need very good controller also. So therefore, this out of many problems will come. The challenges will come. We have to solve it, and then only the smart grid technology will stand. So protection is one of the aspect of smart grid or microgrid. And out of this protection aspect, one I'm just sharing today, just now, the islanding detection. Okay, and some laboratory we have developed, I can share with all of you. So this islanding means what? The word itself is meaning what? Islanding means when this main grid has some disturbance and some problem, and the main grid breaker is open, so rest of the microgrid system is disconnected from the main grid. The islandings are basically two types. One is the unintentional islanding, other one is the intentional islanding. So unintentional means the grid is having some problem and the grid breaker is opened and rest of my microgrid is disconnected from the main grid. So what happened? So I cannot see. I'm not getting supply from the main grid. It is all of a sudden. It is not done intentionally. It is done unintentionally. Okay. So that kind of, if I'm doing intentionally this portion, I'm just knowingly I'm disconnecting from the main grid. Then it is known as intentional islanding. So in case of unintentional islanding, what happens? There will be many issues will come. So therefore, to overcome that issue, we have to detect this operation, whether the microgrid is connected to the main grid or it is disconnected from the main grid. That process is known as islanding detection. That is and we have proposed, I just in a single line I'll tell you, there is a central controller facility in the microgrid system and there is a local controller facility. Okay, and I said from the beginning, the smart grid is nothing, it's a communication between every devices, with controller to controller, with the renewable sources to the controller, with the breaker to the controller, from the load to the every devices we are making smart. Sensors to the controller. So the controller to the sensor. So there is a two-way communication. Okay. So what we'll do, centrally, we will just have some decision taking capacity. What is happening in my microgrid network? That is what is the smart grid technology. It was not available earlier in the distribution network. So this, what I'll do, we are just in our research, what we thought of, like we have a central microgrid control station, and from where we will see these lines, a simple network I have shown in front of you. From these breakers, this is the breaker of my SBDR, means synchronous based distributed energy resource. IBDR means inverter based distribution resource. So they have their own breaker through which they are connected to the main grid, to the microgrid. So from every breaker, the information will come to the microgrid control center, and from this main grid circuit breaker also. So in the main grid control center, we will take the decision whether this breaker is open or not. Okay. So this is one more information. As I said, why this islanding is important. See, as I said, every step should be thoroughly verified. Okay. So recently, ABB has declared they are developing a smart inverter where this anti-islanding feature has been enabled. Okay. It is compulsory now. It is compulsory. Every inverter should be embedded with the anti-aliasing filter, and it should detect quickly the grid is disconnected, and some other actions will be taken afterwards. And not only that, in globally we have International Smart Grid Action Network, and under that Smart Grid International Research Facility comes, and there are many annexures. Annexure 5 is under India. So under Annexure 5 we have power system testing, and again under that distribution grid protection reconfiguration is one of the aspects. See, think globally this is required. So when the globally all meetings will be taken place by all the countries for the smart grid development, so every country will be assigned one of the tasks. So India is assigned with this task, this Annexure 5. So under this we have distribution grid protection and reconfiguration. So why not we should try our best to do something good. Okay. So these are some of the problems when we are not going to detect quickly this islanding, unintentional islanding, like out of phase reclosing, degradation power quality, because when this microgrid is disconnected, so inside microgrid you have you have the power mismatch, active and reactive power mismatch. So let me share with all of you, in a low voltage distribution network, X-Y ratio is very low. So therefore, there is a decoupling, like the P depends on voltage and Q depends on frequency. Okay, but in higher voltage level, it's opposite. But here X-Y ratio is very low, so this decoupling takes place. So this power quality issue means when the power mismatch takes place inside the microgrid, when it is disconnected from the main grid, so then frequency voltage variation will be there. And again, the inverter control mode switching may occur. Because the inverter actually which are used for this solar or wind, whatever the renewable sources batteries we are taking, then what will happen? Then this inverter takes the reference from the grid side bus. When the grid side bus is not energized by the grid, the inverters may switch over to another control strategy. So those problems also will come. Then equipment damage, like if your voltage and frequency dependent loads are there, so they may be affected. And threats to the personnel crewmans. So some loads if here present, so those load, people who are working here, they may get that the grid is disconnected, but however, the renewable sources which are present inside the microgrid, they may impart power to these loads. So there's so many aspects, just I have written in front of you, you can go through further also. Okay. So there are so many conventional technique existing, okay, for detecting this aspect. One is very easiest one is rate of change of frequency, phase zoom detection, rate of change of power, rate of change of voltage. Why it is very easy? Because when there is a power mismatch, delta P mismatch, so obviously my voltage will vary. So I can take the rate of change of voltage, so I can detect easily. Similarly, when my rate of change of reactive power is there, so frequency will vary. So therefore, I'll take the rate of change of the power. But the point is, I can share all together. I just summarized. The problem here is with this technique. Okay, these are followed in industry also. with the zero power mismatch, let us say there is no delta P mismatch or no delta Q mismatch, what to do? Because there is no change in voltage, no change in frequency. So in that case, what alternative we have to do? So therefore, so many other techniques like active islanding detection technique, you have communication-based island detection technique, you have hybrid detection techniques, further detection technologies are developed by the researchers. Okay, so this is how this goes, delta P in the positive direction of x-axis and minus delta P in the negative direction of x-axis, delta Q and minus delta Q. So delta P, all of you can write if somebody is interested. Delta P means P load minus P generation inside the microgrid. It is not P generation minus P load. Okay, this is delta P is P load minus P generation. So delta P positive means your P, when the microgrid is disconnected from the main grid, P load is higher than the P generation. So P load is higher than P generation means what? Load is higher, so obviously the voltage will dip, and there the under voltage relay will work. And in similarly, minus delta P, your P load is less than the P generation. So in this case, the over voltage relay will react. And similarly for delta Q, the under frequency relay, and for minus delta Q, over frequency relay. Okay, so and what is this square black, blue, red I kept? This is known as non-detection zone. As I said before, few minutes, I said if your delta P, delta Q percentage power mismatch decreases like 1%, 2%, 3%, it is increasing. If it is zero completely, then the technique may fail. So that means from there the research takes place. So what could be our possible technique which will overcome this percentage of mismatch, even it is zero, very low, that can also detect my islanding scenario. Okay, that is what is meaning of this box. So one of my student, he's going to pass out from this organization institution. He has developed many algorithms on islanding. He has developed active islanding. So what I discussed previously with you, those are passive islanding, passive unintentional islanding. He has there is, in short, I'll tell you because it's already almost time is going to over. If you're interested, you can interact from onwards, that I can interact with you. So this active islanding means mostly what we are doing, we are actually gathering the voltage first frequency. Let me tell you what is active islanding. Active means the controller of the inverter of the solar or wind or some other renewable sources we are controlling. We are injecting some disturbance to the controller of the inverter and looking some response at the terminal of the renewable source. Okay, so this is our active. Active means we are manipulating the controller of the inverter of the renewable sources. So therefore the name is active. So in this case, in previously there are so many conventional active islanding detection technique, but what they do, they constantly inject disturbances, which is not a good practice. It may violate the voltage frequency constantly, even though it is not an islanding scenario, but it will affect. So, but to overcome that, we have kept one guard like delta F. Here it is. What we did, we measured the frequency of the grid FG as well as the frequency of the DG. This is my DG, renewable. So the difference I took, FG minus FDG. If it is greater than some threshold, then I will just go on injecting the disturbance. Otherwise, no. Okay. So this technique is very, effective, we found. And that's why this name is Active Sleep Frequency Based Islanding Detection Scheme for Grid Tied Inverters. This paper is accepted in Industrial Informatics. You can see this paper also in detail. This is a control strategy of the inverter, and here we injected some disturbance signal to the controller ID dash. It is 1% of the fundamental ID. Okay, so then the controller will react, and corresponding pulse will be created, and it will be supplied to the inverter, that is voltage source converter, and then the corresponding response at the terminal of the DG we have calculated like this. We have calculated the JDH, that is the VDS by ID star. So this impedance at the terminal of the this renewable source we are calculating. If it is greater than some threshold, we will take decision. Otherwise, no. So these are some of the results. Okay. So similar, one more also technique we have taken. Here we are injecting the reactive power. Instead of ID, disturbance, we are injecting the disturbance and the reactive power to the controller. And here we are using the micro PMU because here we need some adaptive analysis because the micro PMU, in the adaptive analysis, we need some voltage current information. The micro PMU can supply voltage, current, frequency together. But in previous section, we have used here FDR, the frequency disturbance recorder. This will supply only the synchronized frequency, no voltage, no current. So you may ask me why we are using this micro PMU, FDR, because these devices are very precision-wise, very small change in the network, and also it can catch. But we have seen its precision is almost 0.0012, if I'm not wrong. So this is a precision level of FDR and even micro PMUs. The small changes in frequency they can catch. This is how this Q reference is injected and corresponding decision has been taken. So these are some of the results. So due to time constraint, I request all of you, you can take over these two papers and you can just have a look and you can read. If any concern, you can always mail me. So this is one of the real-time smart grid laboratory we have developed. So whatever the technique, I say to all of you, like it's an injection-based active island detection technique or passive island detection technique, whatever. So we also implement in a hardware in loop test. We have a real-time digital simulator in our laboratory. And from there, inside this real-time digital simulator, we simulate the smart grid environment like solar, wind, with battery, loads, every realistic environment we create. And from there, the voltage current signals we tap and provide to the DSpace. And from our codes will run here and again we'll reply back to the network. So my question here is, it is okay. It's a child loop. I think all of you know this hardware in the loop test. But the point is why it is necessary, because when we are developing some technology, that should be implemented in a hardware platform. Otherwise, what is in the real-time signal? The real-time signal is nothing the watch, the clock time. If suppose I am simulating something in MATLAB, it is taking 2 seconds, 3 seconds, 4 seconds. But that is maybe 1 minute also. But that is not advisable. That is not the watch exactly what time I need here. It is not like that. So real time means exactly the system, real network, how it behaves. Same system I can mimic here. That is what is the real time concept. And then let me declare this islanding, what I discussed, one aspect of my protection of smart grid or microgrid, that should be detected within 2 seconds, within 2 seconds, maybe 1 second sometimes. So therefore, this 2 seconds or 1 second, how can I declare by simulating within a MATLAB platform? We have to take some hardware implementation setup. So there, the real system we are mimicking inside a small prototype developed, real-time platform. So there we can say, okay, so it will take this much of time. Therefore, this HIL test bed is required. This is one more smart grid lab we have developed recently, Dr. N.P. Vasni Smart Grid Lab. Here also we can go for DC microgrid, AC microgrid, do both. Okay, so thank you all. Any questions? I took long time. I hope all of you are not bored. And thank you so much for your patience hearing.
Not at all, ma'am. Nobody gets bored actually when you.
So I hope I took your long time.
Thank you, ma'am. No, thank you very much.
I'll be very happy.
Somebody is saying something. Yeah, please.
Yes.
Thank you very much, Professor. We appreciate it.
Yeah, thank you so much. Thank you so much. I'm really grateful to all of you. This evening, you are patiently hearing me. So I just tried my best to push some points which are actually I find very interesting during my journey of research. So there are so many aspects. If we'll get some other time, we can definitely discuss.
Ma'am, one of the participants, Rashmi Ranjan Mopatra, she wants to ask something. Are you there? She has written something in the chat box, ma'am, if you can.
Yeah, but implementation across the country holistically is the need of the hour. Yeah, so definitely, see, actually this smart grid, I can say to all of you that it is not actually a dream. It is not actually, it is not kind of a, somebody say fancy thing. No, it is not like, it is a real need today. Without, suppose, if you dream to, like, if you dream, no, this will be a smart grid, this will be our network. No, it is a real requirement today's state. If you are not going for this smart grid technology, we cannot allow penetration of the renewables. We cannot, let me tell you, there are many projects are running, pilot projects from US, UK, India, with many IITs, NITs, government, private colleges, universities, how to test the battery storage. The battery storage is the mandatory fact of the microgrid and smart grid, because if you have surplus solar energy, so you have to store it for the next operation, isn't it? So therefore, the storage is mandatory now in every microgrid. So let me tell you, without storage, you cannot call any network, even though the renewables are present microgrid. You cannot call it. The storage is mandatory. Storage should be there. Then only we can call it a smart grid or microgrid. And along with that, other technologies, smart technologies are there. Okay, so just like sharing with you one fact, in US, like the customers, they have I had a discussion with the Power Grid Corporation of India, one CEO, Deputy Director level, she is there. So she was sharing with us that they are dealing with many online and their projects from India to US. So they're saying the customers can, after suppose morning 6 to 8 from one agency utility, because the cost of that power is less. From 8 to 10, they can tap from other agency where the cost is very less. And after 10, she is going to the, to the office, all the loads are off. And then when come back from office again, depending on the priority, that they will take the supply from the agencies. It's quite amazing. So, it is only possible by the demand side response or demand side technology. And this is part of the smart grid technology. Okay, just I'm saying few lines. There are so many, it's a very vast course. Okay, so yeah. So any questions? No. Somebody is written, Lalita. Is it manual that we have RTDS for smart grid? Yeah, of course. I'll suggest at least some online testing platforms should be there. Not necessarily RTDS. We can take in physical solar module. You can take physical wind module. Have a practical hardware setup as a whole. And you can supply those voltage, current, whatever I'm talking about protection. Somebody works control strategy. You can take the signal directly from that hardware setup to the, to the processor, not necessarily DSP processor. You have many processors now available, like you have FPGA-based processor, NI cards, then you have DSP-based processors. Many processors there, very cheap also, 40,000, 50,000. And one solar panel, it costs around 1.5 lakhs, like, honestly speaking, the RTDS what we have in IIT Roorkee is 10 crores of 6 racks. Not necessarily you will purchase it and you have to give it. You may get purchase like within 8 lakhs, a very good smart grid environment. Yeah. So so we have solar and wind power plants in campus with battery storage. Can we venture to have a smart grid lab by procuring additional? Yes, very good. Slowly you can pick up. Yes. Lalita is SBN. Absolutely. You can go ahead. When India will be fully converted to smart grid, which state is leading in smart grid projects in India? Of course, South. I can say South and Maharashtra to some extent, Bombay. So South, Tamil Nadu has, I had the report. I have the report. I have also connection with one of the state electricity authority board person, that they're adding 50% wind energy to their state electricity board. It's a very quite amazing fact. Even though this Maharashtra, there is a wind facilities very good also in Maharashtra and Tamil Nadu side, the coastal belt basically. But unfortunately in Odisha and West Bengal, they are not utilizing that coastal belt due to maybe poverty and some other reasons and some of the climatic changes and all. So these are some of the information I shared with you. So, okay. Right.
Okay.
Typhoon Michelle. Somebody said me similar typhoon. No. We are using simple RTDS and DSPs. That's all.
Thank you, ma'am. Thank you. Then if you have any query, then we'll give you the email ID of ma'am. Then you can send the email.
You can circulate, Hari, you can circulate the email ID. See if someone is interested, I'll be very happy.
Just now I will give it.
Yeah.
Yeah, so you can type on the chat.
So Ramana, are you there?
Yes, sir.
Yeah, please.
Thank you, ma'am, for enriching us with your valuable words and testimony presence. Also, I would like to thank all the participants. Now the session is over. We will meet tomorrow for Expert Talk 9 at sharp 2:30 p.m. Thank you.
Thank you, ma'am. Thank you for being with us. मैम बहुत अच्छा लगा आपका लेक्चर सुनना, मतलब बहुत अच्छा है मैम मेरे लिए.
It's really, I'm very thankful to you both, and you people are doing great job. So arranging and taking this lot of pain and investigating so many facts which we are not doing. Nice.
Thank you, ma'am. Thank you, ma'am. Thank you. Thank you.
I convey my thanks to all participants for patiently hearing me and giving me chance to share something from my side. Okay.
Actually, we are fortunate to have you in this session, ma'am. Thank you so much.
No. I'm trying. I'm a learner in this field also. So this is actually awesome. So I'm trying to learn more, and I can, if I get some further opportunity, I can share more about it.
Okay. Thank you so much, ma'am. Thank you so much.
Okay. Take care. Bye. So
thank you, ma'am.
Okay, thank you. I can leave now?
Yeah, ma'am.
Thank you.
Sir, please announce the next day session. I think only 30%.
So today's lectures are over. Tomorrow we'll meet at 2:30 for Expert Talk 9. That is by Dr. Subho Upadhyay from Allahabad Educational Institute, Agra. Thank you. Okay, sir. See you.
Okay, sir. Okay.